see. We live, we live. Got Alpha on right away. Alpha, can you say something by the way? I just want to test the audio.
Yeah, yeah. Can you hear me?
Yeah. Yo, chat, how does it sound? Let's see. Audio is good? Alpha, can you say something again?
Yep. Can you hear me?
Okay,
Good.
perfect. Yo, Paul, what's up?
Okay.
Let's get into some coding, straight up. Lungs, detoxification. What does that mean?
Detoxification?
Or
Yeah, I don't
lungs
know what lungs
detoxification?
detoxification means.
Are you quitting smoking? I'm in Canada. Is the lighting worse or good or bad? It's a little dark. Nice, good
Oh yeah,
job.
dude. Are you finally moving away from your
From the hood?
neighborhood? Getting out of the. Oh man.
Nah, like
You do have to move, right? So
all of
I'm assuming
SF is loud like that. Yo, Rex. Like
tweaker
all of
zone.
all, I actually don't live in a bad neighborhood. I'm literally just trolling. I just don't want dogs and stuff, so I'm just going with it. Like I live in a decent neighborhood.
But
But
you do
what's
have
it
to
called?
move, right? I guess, or are you staying in SF?
Like my plan is probably to work like because Meta is in Menlo Park, but my office is gonna be in Sunnyvale. So my goal probably is to. I only have to show up 3 times a week, so I was thinking of literally just getting a hotel and just staying there for 2 days, and then
Okay.
just so I don't have to commute, right? It's like whatever, I'll take it out, but like my rent is so cheap that like rent in South Bay is like 3,500 for a studio, 3,000, right?
Damn. Okay. Yeah.
So I'd rather just pay my current rent in my nice spot and then just like I have other friends who have to go down too, so we're just talking about like, oh, we should just rent a hotel and then just go to work. I mean, everything's at work. The gym, there's a gym. You can eat. Won't staying at not really, because then I'll just be in the office all day, Paul. I'll literally be grinding.
Right.
Like I'll
Streaming
just
from the office, dude. Like people leave, they're like,
no,
I have fire up the stream.
no, I'll get
You'll be
fired for
like the
that.
Amazon Seattle dude, it's like raining and dark, last guy in the office, dedication.
Yeah. No, what I'm thinking is like, yeah, I'll just work all day, but like hotel for 3 days, but then I'll just go out in like Palo Alto and stuff. There's nice restaurants in there. I don't know. I don't think it'd be that bad. We'll see. Worst case, I'll just move. But they told me that if I perform well, that I could just do the SF office. So that would be my best case because I don't want to live in the South Bay because the South Bay is really boring.
Oh, okay, interesting. If you perform well, you can. I heard also, do they have like maybe it's only for seniors and thing? You can get like remote if you work well.
Yeah, everything's performance based. If you
Okay.
perform well, you get what you want, kind of thing. It's like I mean, with every company, it's like that. The only reason they even want you in the office is just because they make sure you're not slacking
Make
off. I'm
sure
pretty
you're not
sure.
doing, you're actually doing something.
Yeah, and remote is kind of depressing. I mean, Alpha knows
Yeah.
that.
Yeah, yeah. It's like, wake up from the bed to the chair. All right, we're in the office.
That's crazy. How do you deal with
Definitely.
it? Well, you only been doing
Uh,
it for a year, right?
yeah, yeah. I mean, there's obviously upsides. Like you don't have to be, well, A, you don't have to be like fully awake when you start working, which is
Yeah.
kind of nice. And also, I feel like if you go to the office, you have to be like fully awake way earlier because you got to like, you know, do stuff, like take a shower, get dressed, whatever, drive. But the upside is in an office, I guess, like, once you're there, you're like ready to go. Where remote, you're kind of like, at least for me, I'm kind of a little bit sleepy and stuff. But also, the nice thing about remote is you can have some weird hours. Like sometimes I'll just like, I think this happens for remote like all the time. Is people just kind of check out super early on a Friday, but then if you feel like you didn't do well enough or not enough, then I can just like do stuff on a Saturday, watch some basketball, whatever. So your hours are like really convenient. You can literally have like the weirdest hours, and as long as you get your stuff done, it's fine. Where yeah, in the office, I don't know if that's the case. Like, do people just check out at like noon on a Friday? Like, I doubt it.
No, people like everyone, but like the work hours are just more like 9 to 5 actually when you're working.
Yeah, so I guess you're not expected to do anything outside of the work hours, probably, or something like that. But
I
when you're
mean, you
working,
still.
you're working. So
What do I prefer? I prefer in office because I like being in the office. I like there's usually food, so I like to eat. Um, I don't know. I prefer. I didn't like remote that much. The main thing I like about remote is that I can just, yo, what's up? The main thing I like about working remote is that you could be traveling, so I could just work from like LA.
the
I could go to
plane.
Canada. Just literally work from anywhere 24/7. I could just keep. I mean, I don't have to be. When I was working remote, I was traveling at least every 3 weeks. I never stayed put in for like 2 weeks.
Oh yeah, that's what. Yeah, I have a friend who does remote. He's literally in like South America or whatever, 24/7, like just working remote.
That's crazy. For a
But
US company, is that allowed?
I think you just can't. I think for us anyway, you just can't like access the production DB.
Yeah.
So if you're like on call, you can't be traveling. But yeah, and you have to only be. I think there's like a 2 or 3 week limit. But yeah, I guess yeah. I guess thinking about it, you don't even have to say that's like vacation time because you're working, right? Like you can go there, you can work, and then you can yeah.
Yeah.
It's not even like vacation time if you actually work during work hours. So it's pretty sick.
Yeah.
And yeah, I think the office also kind of depends on like the company you work at, probably. Like if you're at like a really good company and they have a really good office and food and stuff, then sure. If you're working at a bad company and their office is pretty bad, then it's probably not fun. Yeah.
Yeah.
Also depends the commute. Like my mom is a Swede and she had to drive places that was like an hour, and I was like, damn, dude,
Does
if I have
she
to add 2 hours to my commute or to like my work, plus the office sucks, that would just be miserable.
does
So
she still do sweet?
yeah,
Does she do leak code?
no, she doesn't do. I mean, when she started, she was like a PhD in music, so she moved over here in like 20 2000 or something. So she was yeah, she never worked at like big companies or like famous companies. It was always just some other
Yeah.
stuff. I think she works at like a bank now.
Nice.
Yeah,
Pause like James looking for
yeah. My
coding
mom
interview
leak
with
code.
Alpha's mom.
Dude,
That shit would hit.
she'll get cooked, dude. She'll get cooked with the easies. I mean, she's like in her 60s or something. I don't think.
Uh, Come on, she'll get fizz buzz. She'll get fizz buzz.
Yeah, I mean, probably. But she
That's
knows
sick
she
though.
knows practical stuff. So, and I think she's like a tech lead or something. I don't know. So, yeah.
Does she help you out with this stuff? Like,
Not anymore. When I was doing college stuff, yeah. Like I feel like now it's just not the same. Like we're just doing totally different things. So, not really related.
Mr. B, appreciate you. Alex, what's up? Yeah, we're gonna do some coding interviews and study some algorithms. Yo, Faint, what's up here? What are they saying? Do I get to ride the Meta Cyberbus? What the heck is that? Never heard of it.
No idea. Oh yeah, I got a friend from college that I think works in Meta. He's a senior. He lives in San Diego now, and I think there's like a San Diego office or he works remote or something. Yeah. I don't really talk to him. We kind of like fell out of touch, but yeah, I know he works like in San Diego at Meta. So it's either remote or I'm pretty sure there's literally just a San Diego office.
Nice.
I think I also saw there were like Meta San Diego postings or something. It's probably like really small, but yeah.
It's Oh yeah, I'll be riding probably that bus to commute. Like you just hop on the bus and then you. Is Meta the most paying fan company? I think Netflix is. I think Meta's probably second.
I feel like at that level, it's just more dependent on like your level and like that kind of stuff than the company. So, yeah.
All right, let's get straight into this. Let's hop on.
All right, all
You
right.
already got the bus.
I can add you. Yeah, I got 3 just
I'll
in
record
case.
too.
So yeah.
Okay, I'm gonna start the recording. And then we can
All right.
do three.
So let's do. Let's see. Okay. So I should be
Everyone.
able to just add you.
Oh shit. One sec. Okay, let me do my intro real quick and then we'll.
Okay.
Are you gonna record too? I'll just send
Yeah.
you this too. But you getting interviewed or what? Yeah, I'm gonna get interviewed quick and then we're. Wait, let me open up the Discord quick. There's another guy who's trying to get on, and we have Paul hopping on. Me and Paul are gonna have a conversation about him switching into MLE or machine learning engineer or SWE. That's gonna be sick convo later. Wait, let me talk to that. There's somebody in the chat who had a TikTok interview. Definitely need to get him ready.
Yeah, that guy said he has to leave at 2, so I guess yeah, let's just get going so then he can go
Yeah,
at
let me
1.
message him. Where is he?
Yeah.
Is he here?
He messaged me. Um, he asked if he can go first. Yeah, I don't know if you want to like swap or we can
Yeah,
just
like
go and
I don't
then.
even care to go. I like if he needs a interview, but you're already on here, so might as well.
Yeah, he can just go at 1 then. Yeah, so
Okay,
yeah, I'll
yeah,
message
this one.
him.
Yeah.
And then we can just cut it like 5 minutes short or something if you need to.
Okay. What time? Alpha, then maybe 12 p.m. PST. Okay, Alpha. Let's just hop on a call after this guy. I'm gonna run.
Sure.
We'll run with this guy.
All right, all right.
Okay. Okay, I'll talk to you in a sec.
Yeah.
May 5, first day. Sending you the link. Yeah, I took up an offer at Meta, so I'm switching companies. Let's see. Huge. Thanks, bro. The heck isn't tweaked? The heck? Wait, let me fix my. Yeah, it should be fun. I'm gonna be streaming like learning hack and stuff. I'm gonna be streaming learning hack, which is like the looks maxing startup founder. Don't worry, I'm still friends with him. He's gonna hop on. Yo V, what's up? Yo V.
Yo, could you hear me?
Yeah, yo, what's up? How you doing?
What's up? I'm doing good. How about
Let's
you?
get this working. TikTok?
Yeah.
Nice. How you feeling? Where you work right now?
Um, so right now I just graduated. Uh,
Nice.
s yeah, so I'm just applying for new grad positions.
Nice. Where did you go to school?
I went to UC Berkeley.
Nice. That's it. Have I interviewed you on here before or no?
I don't think so.
Okay. That's crazy. What other companies are you looking to get into?
Uh, this is like the only process I'm in right now.
Yeah.
I was in one with like a startup, and I had one with Oracle, and I went to the final round, then I got rejected then, but that's kind of like the processes I've had.
Okay. I'm gonna look for TikTok tagged real quick. TikTok. They just asked straight like, what's the interview? Wait, actually, yeah, we can talk about this when I record the video. I mean, I guess what's the interview process at
For
TikTok?
TikTok.
Yeah, like have you already
Um,
looked at the discussions and figured out how the interviews go?
yeah, so I mean, I'm not totally sure about like second and third round. I feel like at least from what I heard, there's like maybe 2 rounds of technicals and maybe it's like two LeetCode uh questions like per round, but I'm not totally sure. But for like the first round at least I know like it's just like an hour long. They ask you like 2 mediums, I think, probably.
Two mediums. Okay. So wait, let me write this down.
But like if I pass this round, like I can probably like look into that, like update you.
Okay, they said chat is saying TikTok just ask straight leak code.
Yeah, I think so.
You're saying what's the process? Like a couple rounds.
Yeah, I think it's like honestly, I kind of forgot. Like I didn't really look into it. I was just like, okay, let me just get the first
Yeah,
round
let's
down.
get it.
But
Yo, chat. How's audio, by the way? I'm just finding you some good questions. We could just hop straight into it. Is your leak code user like an alias or because if it is, then I'll just invite you straight to the leak code.
oh, okay, yeah.
Or is
So
it
let
your
me
real
see what
name? Your leak code.
I can pass it to you. I'll DM it to you.
Yeah, send me your leak code profile. Let me see how much questions you did. Okay, nice. It's an alias, so we're good. Do straight. All right, chat. This is the user we're looking at today. 4 contests, pretty good. Mostly doing mediums and hards. So you're probably because you already learned stuff through school. You never had to go through the easies.
Yeah, like the easies I've done are mostly like they were like kind of like stuff like I didn't learn like some weird tricks and stuff.
Yeah, that makes sense. Okay, dude. I wish I could just look up if people did certain questions. Um, did you do 694
No, I don't know what that is.
or just check it out. Like look it up and see if you've already solved the question. 694, like question number 694.
I haven't solved this one. I think I looked at it once, but I didn't solve it.
Okay. Have you done 380?
380. I have not done this one. I haven't seen either.
Okay. Let me just take a look. Number of distinct islands? No, it's a premium question. Have you done 42? It's kind of classic question.
Code 42. Um, I think I did, but honestly, I might have. I don't even probably remember the solution.
Okay.
Uh,
What about 300?
I think I probably did this one.
Okay. What about 207?
I haven't done this one.
All right. Okay. Like how are you with the how good are you with like arrays, DFS, BFS? Do you ever
Yeah,
struggle with
I
that?
think I feel like mostly everything I'm good. Um, I haven't. I've done like a lot of like DFS, BFS questions, but I haven't done like a lot of like graph questions. Like I've been trying to follow Code 150, so like I feel like on that like mostly I did like mostly everything except for like some of graphs and some of greedy and like some other random sections. But like for everything else, I think I'm pretty good.
All right. Cool. All right. Okay. I think I got all the info I need. I'm gonna start a video up. Let's see. Yeah, and you have to go in like 45 minutes. Is it tight?
Yeah.
I don't know.
Uh,
Like if we go over by
kind
10?
of.
Okay, okay.
If we go over by 5, maybe it's fine, or 5,
Okay.
6, 7 minutes, it's fine.
Yeah, we can just do like a 40-minute one. Let's see how it goes. Okay, I'm gonna start it up. Hey
Sounds good.
everyone. So today I'm helping my friend get ready for a TikTok interview. Do you want to quickly introduce yourself? Like what school you went to, where you're interviewing, maybe how many lead code questions you've done?
Yeah, so I'm just I just recently graduated from UC Berkeley last semester. I've probably done like around like 120-ish, 125-ish problems, mostly mediums. Uh, I'm currently interviewing for TikTok. Previously interviewed, like I previously did an internship at Microsoft, and I've done a final round for Oracle for new grad. Um, and there's some other processes I've been in, but this is the current one I have right now.
Cool. Good luck. We're gonna get you ready for it. We were talking to chat, and they're just saying that lead code or TikTok just straight up asked lead code questions. Um, so I pulled up some of the top rated TikTok questions based on frequency, and yeah, we're gonna start off with the first one. Let me generate the link and then send it over to you.
Sounds good.
Oh shoot, I didn't grab it properly. So click it like twice. Sick, you're in. All right, let's get straight to it. So here we're building we're building a data structure. There's three functions that we need to create. Being able to insert into the set, being able to remove items from the set, and then we need to be able to get a random element from the set, right? And each element has the same
Hmm.
probability of being returned, but every function here should be able to be done in O of one time. So we just need to build a set with a get random function. That's the extra thing we have to add here. Does that make sense? I'll let you go ahead and read it and like parse it out and just let
Sounds
me know if
good.
you have questions.
Sounds good. I will read it. Insert inserts an item file into the set is not present. Returns true if the item is present. False otherwise. Removes an item from file. Then present. True. Random element. Okay, so starting off, I think what I see is that insert and remove, it kind of just seems like you're adding to a set, but then I see like get random is kind of asking for one element at random, and I'm guessing that get random, if you call it multiple times, you probably want to get like different elements.
Yep.
Does that make is that like
Yep. It
okay?
should return a random. So pretend we insert 1, 2, 3 into
Hmm.
the set. We should call get random, and 1, 2, and 3 should be returned with 33% probability each. 32.3.
Sounds good. Okay, so it seems like it's saying that it needs to be like O of one time complexity. So specifically for get random, it seems like maybe we kind of need to store like some kind of state. Trying to think about how that works. So I'm thinking about like maybe we insert 1, 2, 3, um, and every time we just kind of have like a pointer and like maybe somehow we're like shifting it. Um, and then if you remove a certain element, then you also need to account for that. Like if this was right here, it would need to maybe be kind of reset. So, and you kind of need to have this be like O of one. Uh, is there like any constraints like O of one for insert, O of one for remove?
It says you must implement the function of the class such that every
Oh,
function
each
works in
function. Okay.
average. Yeah.
Okay. For some reason, I feel like this is kind of reminding me of like LRU cache, where you can kind of use sort of like a linked list approach and kind of keep track of like a certain element and then um, at the same time remove it within your list. So we can start with like 1, 2, 3. So if we have 1, then we can just return 1 every time. So that's fine. If we have 2, then we can start maybe return 1 and then also return 2, like if there's 2 calls made. And then if we return 3, we can kind of um, return 3 because we keep moving it each time we do a call, and then we kind of reset that, kind of bring it back. So what I'm thinking here is that essentially, and also if we do like a remove, so say we remove on 2, then that kind of helps because like we skip that kind of node in the list. And if 2 had the pointer on it, then we can kind of just pass the pointer forward and just delete the 2. So I'm gonna probably try to approach this with like kind of like a linked list class. So I'm gonna make a class node. Within this, I'm not sure currently like what variables we need, but probably just keep, probably will come along as we go. It'll probably come to me. So right now, maybe I'll just do pass, and I think definitely one value is like the val. So I'm gonna probably maybe just put like
Okay,
val
let
equals.
me ask a question here. So,
Mhm.
how is get random gonna get a random value in the linked list?
Yeah, so it's not like, I wouldn't say it's like perfectly random because like each time you're kind of getting one element. So in this case, we have 1, 2, 3. So if we start get random and we get 1, it's kind of it does kind of like depend on the order of like insertion.
Hmm.
So like if we have 1, it will return 1 because there's nothing else in the set. If we have 2, it'll kind of keep swapping between these two, right? And then if we have 3, then it will kind of move forward.
Okay.
Um,
So for get random, what is it gonna do when there's three elements? Is it gonna just look through the three and pick one random one?
uh, so it doesn't necessarily pick them at random, but it kind of is like in the sense that it will pick them on average like 33% of the time. So like if we start at 1 and we insert 2 and 3,
Hmm.
essentially like if let's pretend like we didn't have any get random calls,
Yeah.
then what will happen is the 1 will get returned first, then second will be this 2, and third will be the 3. And then if we call get random a fourth time, it'll go back to the 1. So that way it's kind of like getting each
Yeah.
like 33% of the time, or like 1 over n.
Okay. But it's not really random because
Hmm.
it's now doing it in the order
I see.
that
Yeah.
it was inserted. So it's not random. I can
Okay.
kind of predict it. It should
Yeah, you
be
can.
I should be able to
Okay.
get one, and then the next time I
Hmm.
call it, there should be a 30. It should be independent probability, right? Every time you
Correct.
call
Yeah.
it, it should be 33% chance to get the one. But if I call it once, I know for sure the next time won't be one again. So
Hmm.
it's not random.
I see what you're saying. Yeah. Um, yeah, you're right. Because it depends on the insertion order, so it's not necessarily random in that
Yeah,
sense.
it's like
Um,
independent. It should be like a coin flip. Every time you flip it,
yeah,
it's like fifty
I
percent
see what you're
probability.
saying.
Yeah.
Yeah. Um, I think. Okay, let me think. Um, can I assume we have like any access to like any functions, like any random functions?
Yep. We have access to random functions.
Okay. Um, I have not used random functions in Python, but
Just import
let me.
random, and I'll tell you.
Okay,
There's
sounds good. Okay.
there's different
Um,
functions like random dot int. You
okay,
could
sounds
pass
good.
in value between.
Um, okay, and Okay. We need the removal to be O1. So I kind of think that like my idea of using like the node kind of made sense because you kind of need to essentially when you're removing an element, like if we have this array of 1, 2, 3, the issue is if we remove 2 and we're using like an array, like I'm not sure like the operation time, like how long it takes to remove that 2 and using an array. Um, so I feel like we kind of need like that node to like get that like O of 1 removal.
The
Because
node.
yeah.
Okay. So imagine we had a list of 1, 2, 3, right? Oh, sorry. Like how would you grab a random index from here?
So grabbing a random index, like you can probably assign these indices,
Mm.
um, and then just remove the one, uh, like if you have like a random function and it gives you like an indice, then you just remove, or you just return the one. Sorry, you were asking about get random, or were you asking about remove?
Or get random here, right? So
Hmm.
if we had a list maybe of 1, 2, 3, how do we randomly return a value in there?
Yeah, so if we had a list, I'm guessing like we can kind of, are you asking like the list like in terms of like a list node or like an array?
Or for yeah, just an array because
Okay.
first off, linked list doesn't have random access.
Hmm.
So to get to a value, we need to iterate. So that already
Hmm.
kind of removes the linked list
Yeah,
as
I was
option.
thinking you kind of assign, it's kind of complicated, but I was thinking you could assign the key to be like an index, and then you could pass a value as a node, which would kind of be like a key value pair. So that'd be like a map, but it's probably really complicated. But yeah, for this array list, specifically this list,
Hmm.
you probably just get a random index and then just return the specific element at that index.
Yeah.
Um,
Okay, you just generate a random index in return.
correct,
Okay.
yeah.
That would get us probably like a O of 1 random, right?
Yeah, I think that would. And I think that might give us some issues with insert remove, but we can probably look into that later.
Yeah.
Probably just get
Okay.
started.
I'll give you a small hint that like if you use an array under the hood, you'll be able to
Hmm.
do the get random,
Hmm.
and then let's just see how you handle inserts and removes from
Sounds
there.
good. So, okay, so I'll call it self dot list maybe, and I'll just set it to that. So insert, I'm just gonna do self dot list dot append, and it'll be val. Is there anything where duplicates, like do we care about duplicates?
Let's see. Inserts an item val into the set if not present. Returns true if the item was not present. False
Oh,
otherwise. Okay, so I think it just doesn't do the insertion if it's already in there.
oh, okay, okay. Okay, so then, okay, I'm gonna probably just keep it to a list for now, and then we can probably look into optimizing that later. Um, so, okay, I'll do remove later. I'm gonna work on random. So for get random, we do need, uh, I think import, so random, I don't know like how random works in Python, but you probably have to set it, like seed it, I'm assuming,
For which random?
for random in Python, like,
Let's do. You could do something like just use this. So this returns you a random int between 3 and 9. I think it's inclusive.
oh, okay, okay. That's good then. Sounds good. So I will choose my index and I'll let the index be, I will pass it between 0 and the list length. So self.list and the length of that length.
Nice.
Okay. And we don't want, is this inclusive or,
I
uh,
actually don't know.
okay. That's totally fine. I'll probably
Chat, do you
just
know?
test it.
Yeah.
Okay. And then once we choose that index,
Oh,
we just return.
both included. Yeah.
Okay.
So you
So
probably
then
have
we
the
probably want to do
-1 to.
-1 here.
Yeah, exactly.
And then we can do self dot list, and we can pass that index. So that will give us the random. Now the issue is of the insert and removal. Insert is like O of 1, but we also don't have like a set, so that's the issue. I feel like the node would be like a really good idea because like it's like kind of convoluted, but essentially if you have a node, like if you have 1, 2, 3, you can kind of have a key value pair where you can have, actually this might be, I'm realizing this might not work because you have an index and these indices, I'm gonna make these like something else, like 3, 6, 2. So we need to map these indices to these, and we need to find a way to do O of 1 removal. I'm assuming doing a single pass would be O of n, and I'm assuming that would probably work, but that's O of n. So if we have a set, that would probably be easier in terms of a set would allow us to have like the O of 1 removal and insert, but I'm trying to think about how we can map an indice to that. Because we have indices here.
Yep.
We need to map an indice.
Okay.
So
I mean, here, let's do this. Let's just add the set and then see where. Let's. I think that'll get us
okay,
like
sounds good.
90% of the way, and we'll see.
Okay. I'll just keep calling it list and I'll make it a set. And
Or sorry, I mean, we still need the list to get the random, right?
oh, I see what you're saying.
Yeah. So introduce another set. It's similar to LRU cache a bit.
Yeah, okay. I'll just call it like random set. So this set probably contains, I think, okay, I think maybe this set can contain this set needs to probably contain the numbers because, or it could contain the indices. No, it needs to contain the numbers because we need to check for duplicates. So we need to insert into this set. So and I think the question said return true if it was not present. So if val not present or not in self dot random set, then self not val if val not present, then we're gonna return true after we do the work, and we're gonna do work here, and then otherwise we return false. And so what we need to do here, so looking at this, we do need to insert the these numbers into the set so we can get that O of 1 removal.
Mm-hmm.
Let me think. Okay, let me try doing 2 numbers. So, okay, let's have like a small case like 133. So if we insert 1, that 0 gets mapped to 1. If we insert 3, we have like a 1 indice. If we had 1 as an indice in the random set, then we would still need to check if 3, okay, so we would need to iterate through the whole set, which would not really help. So we do need to have this 3. So the 3 needs to go in there. The question is, what do we do with the list? I think you could do like a weird reverse mapping where you kind of increase the set size, but that's kind of
Okay, we're adding into our set here. What are we? Sorry,
are you
what's
asking what we're
happening?
doing here?
Yeah, like you said, do work here.
Okay, so essentially insert, we need to insert a val into the set if not present. So if it's not present, then we're gonna return insert into the set and then we're gonna return true. Otherwise we're gonna return false because we're not supposed to, I believe the question states that we're not supposed to insert into the set. Okay, let me think. Okay, let's just insert to the set and see what we can do. So
Yeah. We have to
val,
return false if it's already in there.
yeah. with the list, I'm not sure what to do as of right now, but like maybe if I look into remove, it'll probably give me a good idea. Okay, and then val is the same thing, I think. So if val not in self dot random set, then return false. Okay, let's just do if in, and we're gonna do return true, and we need to remove it. So self dot random set dot remove, remove, remove val, and then return false otherwise. Okay. Yeah, and then now the issue is this set thing, get random. So get random, we need to,
I mean, that's still
we're
gonna work.
doing, that's so, sorry, what'd you say?
That looks like it's still gonna work. It's gonna return a random index from the list.
Yeah, that does work. Oh, I see. So, oh, I get it now. Essentially, even if you have the list, like this totally works because like you could just take that number and then remove it from your random set, and then just check if it's in the random set. So now we just check the number, check number. So essentially, like if I'll call num equal to self dot list of index, if it's present, if num in self dot random set, then we can return it, return that num. Otherwise, we kind of need to we can kind of need to like keep doing this.
Yeah, that works.
So yeah, I think this should work. And then the only thing is this might take a while. So it's not really, I'm not sure if this is like necessarily O of one.
Okay.
Um,
I mean, I think it would actually work here because you're getting a random, well, self dot num list. Okay, can you walk me through your code top to bottom, and then maybe we can move on
okay,
to the
sounds
next
good.
one too.
Sounds good. So we have self.list and self.random.
Okay. What are these
So
for?
self.list, essentially we need to get a random item within the list, and that random item will be like a num value. So essentially, like if you have like 1, 2, 3, then that will be inside the list, but it'll also be inside random set. And the reason we have this list is because it makes returning a random item easier.
Mm-hmm.
Because I'm not sure if there's like a way to like return a random item within a set.
Mm-hmm.
And then insert. So insert basically if it's not within the random set, then we can add it to the random set and add it
Yep.
to, we can also append that same value to the list.
Mm-hmm.
Um, and then I think the question said to return false and true in case it was in set, which I do as well. And then
Mm-hmm.
we have remove. So remove, we just remove it from the set, and we don't remove it from the array because it's gonna cost us like, it's gonna, I'm not sure like the runtime, but I'm assuming you have to find the
Mm-hmm.
element, remove it, which takes time, which might be like,
One time.
yeah,
Issues.
not because of, yeah.
You just think it's like O of n time to remove it because it's not linked list?
Oh, I see. I think one thing that we could do is we could actually, um, inside the list, actually, no, that wouldn't work. Um, if we actually made this like a map, I feel like you could, but that's, sorry, wait. Yeah, like if we had a map, let's say we mapped indices to values, then we could actually, I'm not sure if that like allows us to go into the array and then remove it, or if we pop like a certain index, I'm not sure like the runtime of like popping from a certain index in a list, if it's whether it's O of n or O of one. But that's probably an approach that could work
Mm-hmm.
if that was O of one. But yeah, I'm not doing it because I'm not sure about the runtime.
Yeah.
Um,
Okay. Let me see. So yeah, you don't want to remove from the list.
mhm.
Okay. So Okay, let's look at get random. Can you walk me through line by line, and then we could
Yeah,
address that
so get
final part
random.
after.
So we have index. So we're essentially just getting a random index within self.list,
Yeah.
and essentially while true, if that thing is within the random set, we get an index, and then using that index we get one of the numbers within the list, and we just check if it's within random set and we return it. Otherwise we
Otherwise,
keep looping.
okay. Does the loop look
So
correct
this
here? Is there any bugs that you might see with the loop?
Oh shoot. Yeah, we're not generating the index each time, so that's one issue.
Okay, cool. I think this would work. Like one way we could probably speed this up is like if we see it's not in random set, remove it in random set. Or actually, oh no, because you don't want to remove from the list. Okay, let's go back to this remove. You're saying we're not removing because of the runtime issues O of 1. So pretend we had a list like this, right? 1, 2, 3, 4, right?
Mm-hmm.
And we wanted to pop 1.
Yeah, so
What happens
I'm
when
not
we
sure
remove?
I'm not sure like under the hood in terms of like how Python treats lists. Like I'm not sure if of if we had like for example just 1 2. I know Python, I think if you pop from the end, like I know it's like O of 1, at
Mm-hmm.
least that's what I think.
Yeah.
But I'm not sure if like you have for example like something like this, if you pop 2, I'm not sure like what the runtime is like, because I know you can pass the index, but I think it's probably O of 1, but I'm not sure.
Well, yeah, okay.
Um
I'll tell you now that removing from anywhere but the end is gonna cause all of the elements to the right of it to shift over. So if I remove
mhm.
1, then we'll have to shift 2 here, then 3,
Okay.
then 4, and that's gonna lead to an overrun operation.
Yeah.
So you're right that there's a runtime issue there, but there's like a neat little trick that you could probably do here. Is just like if you, like you said, swapping from the back is O of 1. So if we swap 4 with 1,
Oh.
we could just sort of just pop it out, and that's O of 1 operation.
Oh, dang. I didn't.
Yeah.
Okay.
So yeah, go ahead and try that question. Let's move on to the next question.
Sounds
But yeah,
good. Yeah, so
that's a TikTok tagged one. So let me
thank
end
you.
here. Yeah, we'll go into another one real quick, and then let's see. We'll probably spend like 15 minutes on it as well. Like we're right now we're focusing on breadth over depth. Like I don't want you to struggle with too long. So
Yeah,
that's why I
sounds
was.
good.
Let's see. Okay. All right. Let's get into this sec Q2.
Okay. Okay, so I'll just start reading the problem. Value
Yep.
binary tree nodes. You have n binary tree node 0, n minus 1. Where node I has 2 children, left eye and right eye. Return true if and only if all given nodes form exactly one valid binary tree. If node I has no left children, then left child I will equal -1. Similarly for child 1. Find that the nodes have no values and that we only use the node numbers. This problem. N equals 4, left child equals 1, -1, 3, -1. So 1, -1. So this input 1. Okay, I'm just kind of looking at the input, like the first input. So I think what this problem is saying is essentially like you have n binary tree nodes. It says number from 0 to n minus 1. Each node I has a left child and a right child. And if it's like a null or like none type will just be -1, and we want to return true if it's like a valid binary tree.
Yeah.
And looking at the first input, I kind of notice, so we have n equals 4, so it's going to be from 0 to 3. And I notice like, I think this is kind of going by levels. So like this list, so there's no like tree node class or like some kind of node class in this, right? So we're
Mm-hmm.
kind of using like this list. So
Mm-hmm.
within this first input, I kind of notice it's kind of, you start with the node, which is 0, but then after that, then it actually will give you the children. So left child says 1, right child it says 2, which are the first indices. Then it says -1 and -1. So I'm trying to think, what is like the -1 represent in terms of like this, the first index here for left child? Is it like the left of the first child?
-1 means that it doesn't have a child.
Okay, so it just means like -1. So like in this case, like the 1 node, it kind of has like a left child, but that left child is actually -1, so it's like a none type.
Yeah, exactly.
And
So
then,
if you look at example one,
mhm.
so okay, I'll explain the question real quick. We have n binary nodes numbered from 0 to n minus 1. So the left and right child, so the 0th child or the 0th node, you could find its left and right children using the array. So if you look at the 0th element in the left child, that's going to tell you the left child of the 0th node, which is 1,
Mhm.
and the right child of the 0th node
Oh,
is
okay.
2,
Okay, I
right?
get it now. I see. So it's like, so then the pairs are basically the index refers to like that child. So like the 1 has -1, -1 because there's no children. The 2 has 3 and -1.
Yeah, you
Okay.
could see 2 has
I c
3 as its left child,
yeah,
but
yeah.
-1 because it has none if you look at the visual
Yeah,
there.
sounds good. Okay. Yeah, I think I get the input and I understand the problem. Let me think about a solution real quick.
And like one tip is like I would just jot down some notes on the thought process so the interview kind of following where you're thinking here.
Okay, sounds good. So far, like I'm kind of just like looking at this. So I realize that we have 0, and then I'll call this index 0, just, or I'll like call it, I'll like one index it, so that way it's like not confusing. But basically this is kind of like the, or actually, so for 0, we do have the input, so it's gonna be 1, 2, and let me just copy this maybe. So 1, we have -1, -1, and then for 2, we have, what is this? 3. Left child is 3, and then the right child is -1.
Yep.
So looking at this, I'm kind of seeing like maybe we can have some kind of recursive function that we basically need to pass in maybe like the index of the left and the right child, and we just need to make sure that the value is correct. So maybe I'll just call it like, maybe I'll start by creating a function. So within this function, like we kind of need to think about what inputs we need to do. So we need to, I'm thinking the way this is going to work is we're going to return some kind of true value if all of the cases pass in terms of like its children. And I need to think about what kind of inputs we need to pass down to the children in this recursive function.
Let me
So
ask you this question. Like, how do we validate something as a binary tree, like a valid binary tree? Like, what are the properties that make something a valid binary tree?
essentially, oh yeah, I forgot to mention this. Essentially for a BST or binary tree, we know that the left and the right subtree, so the left subtree needs, like all the values within this left subtree uh need to be basically whatever the root of
Well,
the binary tree
or this is just a
is.
binary tree, not a binary search tree.
Okay, I think the difference then is, uh I'm assuming it's just that it just needs to be, oh, this is 2, 3. Um, okay, I'm not sure what the difference is between a binary search tree and a binary tree.
Like
Um,
if I give you a binary tree,
mhm,
like how do you know if it's invalid? Like what makes a valid binary tree, not a binary search tree, just a regular binary tree. Right? Let's talk about the properties that makes it there. That makes
mhm.
it binary tree.
Um, I'm guessing it just has 2 children, and uh, each child just has at most one parent.
Okay. Or write that down. Just like, write
Okay,
down the notes. Yeah, that's important.
so each node has at most 2 children,
Okay.
left and right,
Sure.
and then uh each yeah, I think that basically captures it, and then each parent has at most 2 children.
Or that's the first condition you have there, right? Each node has its own.
Yeah, that's like the same thing. I think that's so yeah, like in this example we have 2 parents, so that doesn't work.
Well, you mentioned one thing is
Uh,
like, can one node have two parents, or it has to strictly have one?
yeah, so it should okay, so each node has at most one parent.
Okay.
Uh, yeah, okay.
It's like, can it be
Um,
disconnected? The graph.
okay, yeah. The graph cannot be disconnected. Or I mean, it should only have like one connected component, really, if that makes sense. So like,
Yep.
uh,
Yeah. Like it's not a forest, right? It's a tree. It's like,
mm, sorry, I'm not sure what
oh,
forest
sorry.
refers to.
Or forest means like it's not like a forest, as in there's only one root node kind of thing, and
Oh,
it's
okay,
not
okay.
like basically what I'm saying. If there's like five trees, that's a disconnected
Oh, okay,
component. So
okay.
you
I see what
mentioned
you're
it's like a
saying.
forest of trees.
Yeah,
That's
yeah,
what
yeah, I
they
see what you're
call it.
saying. Oh, okay, okay. Yeah, not a forest. So you only want like maximum like one root node or just one
Yeah.
root.
Because you think of example one, right? If example one, if you combined it with example two,
Mhm.
like, but
Yeah,
they're
so if there's two of
independent,
them
yeah,
side by side, then it would not work.
it would not work, right?
Yeah,
Or even
sounds
if you
good.
take two example ones side by side, is that a valid binary tree? Probably
Two
not.
example ones side by side.
Yeah,
No, that would not be valid because you have 2 roots.
yeah,
And they're disconnected. They need to be connected. Like they have everything needs to be connected to like a root, essentially.
yeah.
Like from the root, you should be able to reach everything. Um, okay.
And then
So I
I'll
think.
give you one last sentence. Like, there should be no cycles.
Oh, okay, okay. I see what you're saying. Yeah. Um, so we need no cycles, and we need like from the root, we should reach all nodes, or like reach all. I guess you can call it nodes, or all children in this case. Um,
Okay.
okay. So with all this, let me think. So we first of all we need to make sure. So in this case, like if we had 0, 2, and 1, would that also be a valid binary tree?
Oh, sorry.
Um,
Could you repeat that again?
so if we had like a tree, so like in the first example we have 0, 2, 3. If we had 0, 1, sorry, if we had 0, 2, 1, would that also be a valid? And the 1 would be like the left child.
0, 2, 1. Okay.
Let me maybe draw it out kind of like this. So kind of like this, where the left, the 2 is the right.
Like basically like this, right? You're asking if this is valid tree?
I'm asking if if this is a valid tree.
What do you think?
Um, I think it is. Um, I think it's like it fills all the conditions that we mentioned.
Yeah, yeah. So if it
Okay,
fills
sounds
all the
good.
conditions, like every node has at least, or it has 0 to 2 children. It's
Hmm.
not disconnected. Like
Yeah,
no cycles.
sounds good. Okay.
Yeah.
Yeah, then okay.
So since we only have a few minutes left, I'll just quickly
Mhm.
ask, like, how would you pretend I gave you a root node of a
Okay.
tree?
Okay.
How would you be able to verify that it's a valid binary tree?
Yeah, essentially, like you would just need to make sure all the numbers from 0 to n minus 1 are within that tree. So you can maybe have like a set, and like essentially you kind of do like a DFS, and uh once you find a cycle, then you just want to return false, because that means we did not reach, or like we reached a repeated value.
Yeah.
Um, and then if once we do the DFS, if the length of set is not equal to like n minus 1, then we can return false as well, because that means like the disconnected component.
Yeah.
Um, so that would be how I would do it. Specifically, I'm not sure if yeah, so for the cycle, I guess if you just run into something val that was previously in the set, then you would just return false as well.
Yeah. Okay.
Um, and then once you run into all this and you see that it is n minus 1, then you return true. That would be kind of like the
Okay. And what graph traversal algorithm are you going to use for this?
I think you can just run DFS.
Yeah.
Uh, and the reason for that, I think, because like if you run to a cycle, like it'll just be, I mean, I think I'm not sure if BFS doesn't work, but I know like DFS works, because you will definitely run to a cycle if you running DFS. Um, but yeah, I would just choose DFS, and I would use a set. And so the time complexity would just be number of uh number of nodes, so just n, and the set size space complexity would just be O of n.
Okay. Cool. All right. Since we only have a few minutes, like, how do you think you did on the interview?
Um, I think I I didn't do too great in my opinion. Like in terms of, I feel like for specifically for first question, I wish I knew how random worked. I think that's like one thing.
Hmm.
Um, I think explaining my thought process, like I feel like I'm good in terms of like explaining my thought process. I feel like in terms of like problem solving, sometimes I think obviously I probably just need to do more problems. I was not like uh and the thing is, another thing is, I noticed specifically for get random, because I've not run into problems where like I need to delete from array. I think I knew the runtime, which was like O of n
Yeah.
for deleting something, but I was like not really confident. I think that's one thing that also showed, like not really confident in my knowledge.
Yeah.
Um, and then specifically for binary tree, I should have known the definition. I thought binary.
Yeah.
I kind of have not probably done a lot of binary tree problems. I've done a lot of BST problems,
Yeah.
so I was getting a little mixed up there.
Yeah.
In terms of like problem solving for this specific problem, like I guess I knew the approach, but I kind of need to be guided there a little bit.
Yeah.
So
Yeah.
yeah, just like overall, I think not super strong, but uh, I mean not the worst, but like yeah, definitely not super strong. Like I need to work on it a little bit.
Yeah.
Explanation wise, I think I do explain everything, but that's probably like the only
Yeah.
thing that was really good in this interview.
Okay. Yeah. Let's talk about this a little bit. I think yeah, you definitely know your Python syntax and are able to write the code. Let's talk about the first question. I think one thing you could do is, yes, you're explaining what you're thinking, but you're more just like, I would jot down notes because you're just
Hmm.
saying it kind of out loud. But
Yeah.
like you should jot down some of the key notes because
Hmm.
also at the end, like an interviewer might forget what you said, but if it's right
Oh,
there
okay.
written, they're gonna know. Like here, you don't have much notes. I don't know your thought process here at all. I just see the code
Hmm.
at the end. But
Hmm.
you see in the second question, you at least are listing out the properties.
Hmm.
And also when you write notes, you could just refer to it later. So
Yeah, that did make it easier. Like when you kind of told me like to write it down, that really like kind of helped me actually because I noticed I was just like, okay, let me read what I just wrote down. I was like, okay,
yeah,
uh that helps.
like what
Um
I do is when I'm reading out the question, I'll
mhm,
parse out some of the important information, maybe a few notes. So I think you're explaining your thoughts, but like get used to jotting them down quickly, because this is a skill even for being an engineer. You're gonna be in meetings, you're gonna hear stuff, you're gonna have to jot it down real quick, because you're probably gonna forget after the meeting, especially if you have like 5 meetings that day. So
mhm,
being able to take notes fast is an important skill, and being able to figure out what to write down. So I would practice that when doing the questions, being able to parse it out, list out my thought process. Because at the end of the day, like I've interviewed people, I forget their whole thought process. I have to look back on the notes, and
mhm,
sometimes when they have good notes, it just makes it easier for me. Okay, they understood that we're gonna like the properties of a tree and stuff.
mhm.
So that's.
Um
Or go ahead.
yeah, so I think like in this question specifically, I think it was really nice because we did like these test cases, or we also listed out like the pseudocode kind of
Mm-hmm.
in in uh in the get, insert delete get random. Would you kind of want to see this approach where you kind of like jot out like a normal like because I feel like that one kind of had like a lot of stuff going on,
Yeah.
so it was kind of like
See,
it's kind of like
yeah,
hard to write this.
exactly. I like how you did it here, where you're like, okay, this is what I'm gonna do. I'm gonna find cycles by doing a DFS and return. Like you're just listing at a high level, and then we could
Hmm.
kind of agree on that approach, and then you can go and implement it. The
Hmm.
first question, you kind of went straight into it, and where you're figuring out as you went, and it lead
Hmm.
to a bit of like churn in the approach.
Hmm.
Versus like
Hmm.
if we talked about it up front, maybe we could have got to the case where, oh, I didn't want to use a list because I don't want to remove ON, and we could figure that out.
Oh, I see. So you
For
kind
example,
of that way you're getting help from the interviewer instead of just like going into it and like getting lost.
yeah, like here,
Okay.
I'm just like here. I actually pretty confident that if you start writing the code, it would work. Versus with the other one, we were kind of running out of time, so it's like, okay, let's just go see what you can do and work from there. But ideally, you want to list out a lot of things up front. So yeah,
Sounds good. Yeah, that was really helpful. I think it kind of gave me like good
yeah.
idea.
I would say for an
Yeah.
interview,
Mhm.
to pass the interview, you would also need a little bit less guidance. So I gave a little bit too
Mhm.
many hints. So I
Yeah.
would be able to try. You get marked on if you're able to get to the optimal solution with minimal
Hmm.
hints. So I think that was
Hmm.
already a bit too many hints. But
Yeah.
I think that could only be solved really with just more questions and more practice.
Yeah, yeah, definitely. Yeah.
Um,
Yeah, I have it by the end of this week, so I'm definitely gonna do a lot more problems.
you got this, man. And then
Thank you.
one last thing I'm gonna just mention is just like just take a look back at some of the data structures and understand like the runtimes and
Yeah, yeah.
understand like yeah, just look at the data structures and understand okay, arrays. What are the basic functions in array? Insert, deletes. I think you kind of understood it, but I'll just write it because you're like, okay, this is why I want to use a linked list so I can do O of one deletions. Like you understood the
Mhm.
runtimes, but you just sounded not that confident. I would just look back at the arrays, linked list, sets, binary trees, understand the properties and understand the common functions out of those. And I could probably send you some of my vids. I did one on all this data structures, and I list
Mhm.
down like what you need to know for an interview for those ones. But I think
Yeah.
having those is a good foundation as well. Like you definitely have it, but you're a bit
Yeah, I just need to solidify it.
yeah, solidify it more. But yeah, thanks for taking the
Yeah.
time out to interview. Good luck with
Well,
everything. Just message me.
thank you for the interview. This is like really helpful. If anyone wants these notes, I can maybe put in the Discord.
Yeah.
Um, but yeah, thank you.
Cool. All right. Catch you, man.
Take care. Bye bye.
Michael, what's up? Best way to study data structures and algorithms. Yo, Paul, what's up?
Yeah, what's up?
Let's see, just setting up.
Yeah,
Yeah,
got
you
you
like
two
this
stream.
question? I actually like asking this question because then I get to understand. Oh, you can hear me, right?
Yeah,
Like I don't know. This is one of my favorite questions because then I get to understand how well they think about or if they understand binary tree like graph theory or tree theory kind of thing, right?
yeah. I mean, like, I guess it I guess it doesn't necessarily say it's a balanced tree either, so you don't even need to verify that.
Oh, there's not a
I was like,
balance tree question.
Yeah, I was like thinking you'd have to verify that it's balanced, like the level of right or the height of right is like at least within one of the left, but it doesn't even say that.
There's another question like that. It's like validate this is a binary search tree.
Yeah.
Here, try this question out. Let me get some water. I'm gonna send this to you.
Okay.
Write this code out. Better have it implemented by the time I come back. Because if you could do a hard, you could do this. Alpha, are you free in an hour still or no? The coding one with me? Me and Paul are just gonna quickly talk about career and stuff. Yeah, okay. Okay. Explain your thought process. I'm gonna be right back.
All right. I think like for this one, I like talking about it in chat. I think just a BFS on this is probably the easiest way. Also just did this one, so like it's not really me going at it raw, but I think like easiest way to do it, just have BFS for children. If we see a node twice, return false. And then at the end, return all visited. So I'm just going to do create visited. And I'm also going to, oops, what?
Yo, Paul, I'll be right back in 5, so just hold it down for a sec.
Create a set of both these lists so I can determine which one is the root. Default it as 0, I guess. And children. So now we have the root. I'm just going to create a queue, do a BFS. Yeah, just put the root in the queue. And then if node and visited, just going to return false because that means that there's a cycle somewhere. We're just going to add it to visited. And then I'm just going to say if left child because it says here -1 if there's no child. So if there's a child, we're just going to queue up and do the same thing for right. Just going to return that all nodes are visited. And I think this should run. I don't think there's any syntax or anything.
Yo,
So
how's it going? I mean, who says 0 is the root?
I mean, it's not saying. I'm just initializing that, and then I'm finding the
okay.
root.
I see. That makes sense.
Yeah, I think if I initialize a root inside of the loop, I don't think it carries outside of the loop, so I have to initialize it before the loop. I'm like pretty sure.
Wait, what's children here? Why are we doing this?
Because it gives you this set of left child, and right child are just all of the nodes that are children of some something.
Uh-huh.
So if we create a set out of both of them, and then anything that's not in that set is the root. And if there's more than one thing in that root, then that means it's wrong, but that'll get caught at the end here when we check that all of the nodes are visited. So we're only checking like the children of one root node.
Mhm.
But if there's multiple roots, then it's not right anyway, so it like doesn't really matter. And we'll catch
I
it
see.
at the end.
I see.
It
Is the
does
code-
carry outside. All
Is the
right,
code
all
working?
right, Alpha. Yeah, it works. 99% beats runtime,
Sick.
at least for me.
Nice. Yo, chat, can you hear my voice fine? Yeah, let's turn it. Was the audio good, Paul, by the way? Or was the guy louder than me when I was on the last one?
No, it's fine.
Cool. Okay, let's write some notes. Let's see. So you're right now you do data and you want to switch into.
Yeah, I don't know if I want to switch into Emily or like Sui. Probably like Emily sounds cooler, but like I also don't know if like I'll get hired for that, if that makes sense. It's like pretty competitive.
Okay, I'm gonna start a separate video on that. Yeah, we could just chat about
I
it.
was thinking I'd just make like a resume for both and just like spam apply to both and then just take whatever I get.
Yeah.
Just like the data stuff is so boring.
Okay, I'm gonna start up a video. Put in some lotion. How's the last guy? You think any advice that you would give to him?
I think he just I don't know. I don't think he's done enough leak codes. Like because TikTok they'll be asking double hards. So like I'm surprised he got through the OA, to be honest. Like no offense to him, but like surprised he got through the OA because like Alpha and I were talking in the chat and we both had OAs where they had us like 1 to 2 hards and we both got like perfect test cases and neither of us got interviews or anything. So I don't know.
Yeah, I mean that's what these big companies do. It's kind of annoying. They kind of like they make you do this OA, you ace it, and then they don't move forward. It's like, bro, that's so terrible.
Yeah, I imagine I don't like. Yeah, like no, I'm not trying to blame the guy, but I'm surprised he made it through the OA there because like the one they asked me was pretty hard, and
Yeah.
they're like notoriously hard.
First off, if you pass it, if you ace it, then they'll look again to see what school you go to. It's like there's two filters.
Yeah.
First, ace it, then is your
Yeah,
resume good? Is your school good? Like,
yeah. It's like why don't they do the first step before the OA?
yeah.
Doesn't
Like,
make sense.
oh, okay, and I mean, yeah, Alpha went to a good school too. All right, okay, I'm gonna start up a video. 3, 2, 1. Hey everyone, so today I have Paul in the live stream, and we're gonna talk about switching from data engineering to something like SWE or machine learning engineering. We're just gonna figure out a strategy for this because he works at data engineering. Actually, Paul, you want to give a background and stuff like data and like where did you go to school? What kind of stuff did you learn? I know you're in your master's at Georgia Tech right now. Yeah.
Yeah, so like I went to school at like a pretty mediocre school, like top 200 type public state school, whatever, because I couldn't get money for anywhere else. But like, yeah, I mean, I'd say I learned a pretty good amount of stuff. We learned a lot of like CS theory, you know, like data structures, databases, all that stuff that you normally take. And then we also had like a few engineering classes, like electrical type engineering or computer engineering classes. So like a few hardware classes, embedded systems and stuff like that. It was like mostly just standard. I feel like most of the schools teach pretty much the same stuff. And now I'm doing my master's in like specializing in machine learning at Georgia Tech.
Okay, so you went to state school. State school. It was in the Midwest, right? State school.
Yeah. Like I have good like GPA and stuff though, so I don't think it's like too terrible. I don't think it's like good, but I don't think it's like the worst thing because I know a lot of people like will go to like Berkeley and get like a 3.2. I feel like that's like worse than state school 3.9, but I don't know. Maybe I'm wrong.
So we went to state school in the Midwest. Good GPA. Traditional computer science degree.
It was technically computer science and engineering, but basically, yeah.
Did you do any internships?
Yeah, I did like 3 cycles at a company. We had like co-ops. We do like the Waterloo co-ops where they like take off school for a few semesters, but we only do 3. They do 6, and our school's like 4 years instead of 5.
Um, what kind of work did you do in these co-ops?
Uh, to be honest, like it was like similar to like data engineer, but I pretty much did nothing. I just sat and did nothing for the entire time.
That's what
So I didn't
happens
really learn.
sometimes. Similar
Yeah,
to
but honestly, like with how generic the title is, it was just IT intern. I could probably just spin it to
okay.
say I did whatever because they just named all their interns that. So I could probably spin it because they have like software engineer stuff there too. So I could probably just spin it to whatever.
Okay. So state school, bachelor's in the Midwest, did a few co-ops. Did you do any extracurriculars other than that? Like
Um,
competitions? Um,
Not since high school.
okay.
I did like math comps in high school, but I stopped in college. Well, like middle school and high school. I stopped in
Oh,
college because like I just there's not that many of them unless you go to good school.
what about like hackathons and stuff like that? Did you do any of those?
I went to one, but I didn't really I didn't really know what was going on. I just kind of went to it just to see what was up. I didn't like do anything there.
I see. When it comes to high school. Okay, now you're at you're doing your masters in Georgia Tech.
Yeah.
Okay, what's a data engineering role, anyways? Honestly, like, what do you
I
do
think
there?
so. Like a lot of what I'm doing now is just like building out pipelines. So just like we use Argo and Airflow, depending like 'cause
Okay,
we have basically our company's like 2 companies merged. We use Argo and Airflow. Um, but yeah, basically just building out like the ETL workflows for those.
so what does that
Sometimes
actually
creating
look like?
dashboards.
Like
Like basically just you like write SQL code and then you create like JSON templates. At least with Airflow,
mhm.
the way we have it set up, and then we have like a migrate Python script. It's like an in-house script that just does everything else. So like occasionally tweaking that.
Okay,
Uh, and then also I was like working on an ML project for a little bit, but we finished it, so there's not really much more to do on that.
okay,
Uh, we were like creating optimizations for credit unions to like make have less manual application review. So I was working a lot on that, like on the creating the model and stuff.
okay.
So that was just kind of like a side project there. It wasn't really data engineering though.
I see. So you're kind of considering switching into MLE, which is machine learning engineer, or software engineer, and you probably prefer machine learning so far.
I mean, probably just because like if like otherwise I feel like my master is kind of like wasting time. But I mean, I'll probably take either. I just like the data stuff is so boring. It's like so repetitive.
Yeah, let me think about it. Cause yeah, I pretty much only could give advice going to software engineer, but then we could explore machine learning engineer. I don't know many people who are actually machine learning engineers. Um,
Yeah, I think a lot of those are like PhDs.
yeah, but what I am noticing now though is they're not becoming PhDs anymore. Like machine learning engineer role is becoming more like application layer stuff. So
Yeah, yeah, that's what I've noticed too. Is like a lot of them are just like basically SUI, but just with the title of MLE.
yeah, and you're gonna so there's like the research portion of it, right? Most of these companies there's a research portion of it, and then there's the application layer. So building applications that leverage the AI, and both need to be in the company. Otherwise, why would you build this model if it's like GPT, the research
Hmm.
portion? Like now, OpenAI, most of their engineers are working on application layer stuff. Like how do you serve these models? How do you build good chat apps? All these GPTs and stuff. Like all these new features help drive the research. Like if they just did the research without building this application layer stuff, they would have never popped off like that, right?
Yeah, I think like the research stuff is cool to me. I just think it's more PhD type. At least in short term, maybe like in 10 years or something. But I know like a lot of like the research stuff is basically like researching optimizations. There's like a lot of math, so I think I'd be good at it. But I'm not gonna do a PhD. It's like too much work.
Yeah. So I think, yeah, since I agree, like, I think if we talk about moving from data engineer to SWE, I think that's a good,
Yeah,
and then transition maybe to a machine learning engineer. Because I think
yeah.
these days,
It's like Sui that works on an ML team. You could probably transition a lot more easily, like just
exactly.
within your own team or org or whatever.
So since you're working at data engineer, I would probably think about it in a few step process of maybe going from data engineering to software engineer. But maybe if I would apply for both, so maybe you could skip.
Yeah,
But one transition that's kind of smooth is like, yeah, maybe working at data eng and then maybe you switch over to software engineer and then focus in on machine learning engineer. Because the way
yeah,
I see it too is like things, SWE is a bit more general, and you learn a lot of things that could apply to machine learning engineer that will help you become a better machine learning engineer as well. Like
yeah. I agree.
understanding the whole ecosystem of how software is built, how software is deployed, how software is used at scale is important for a machine learning engineer, especially one that's working on the app layer, right?
Yeah, I agree. I also think like it's easier to transition from like with a master's in ML from SUI to MLE from than like data to MLE, most
Yeah,
likely at least. I would guess that.
yeah. So let's just talk about your experience right now. So if we wanted to get into software engineering, let's just talk about your experience. Let's start off with the back end. So what databases are you familiar with?
Uh, like Postgres, Redshift, SQL Server, I guess, but no one really uses that. Um, I've used I've used like Mongo a little bit, but not. I wouldn't say I'm like super good with it, but it's like not that complicated.
Okay.
So it's pretty. I'd say I could probably like ramp up quick enough.
So how deep do you know about Postgres?
I'd say pretty deep. Uh, like pretty much any querying stuff is pretty easy, I think, and like optimizing queries. I guess I've not used like the Postgres CLI or anything, but I know it's pretty similar to just like running queries, just like a few different things,
Okay. So you're pretty
like a
deep
few
on
different
Postgres.
APIs.
Okay, you understand like the different aspects of Postgres, optimizing queries. What about at a high level, like data modeling in general? Like taking like a business use case and then modeling the data. Similar to what you saw me and Alfred working through the hotel reservation. Like if I gave you a random problem, would you be able to
Yeah,
model the
I
data?
think I could probably do those pretty well.
Okay,
I think I'd probably be better at those than the normal SDIs that I've seen you like give alpha.
okay. Pretty good at modeling. Pretty good at modeling data. So yeah,
Yeah,
you
I know
know,
like a lot of data engineering roles have those type of system design interviews where it's like pretty much just a data modeling.
I see.
So
Okay.
I think I'm good at those.
What about infrastructure stuff? Are you familiar sort of with um or okay, wait, let's talk about this, right? So you say you're pretty good at Postgres optimizing queries. What experience do you have that you could write in your resume that will show that you could do this?
Um, Pretty much all of them.
Okay. Like give me a
Just like
couple specific bullet points because what I want to get out this conversation is like this is all the stuff you know. These are some bullet points that we could add to your resume and make your resume fit the software engineer role.
I know like with that ML project I was telling you about, I basically like the queries that they had were just raw querying pretty much everything.
Hmm.
So I just had them basically use like CTEs to do better subqueries, so it would not use as much buffer space in the like in the Python because
Hmm.
I don't know like usually SQL is able to query between stuff better than like a pandas data
Hmm.
frame can filter it. So I just basically rewrote those to do all the querying in the SQL instead of doing like a bunch of filtering in the pandas and taking like 10 minutes to run a model. Uh,
Okay, so your ML project has some good, like your ML project at your current work has some good bullet points that we can add to show that you know databases.
yeah,
Okay, and then you said your current experience helps like with bullet points, helps with this.
yeah, that was.
Okay,
What do you mean by that?
So yeah, just like because what I'm trying, like basically we're saying your current experience will help us create some bullet points later because we're gonna work on your resume offline a bit, but we're
Yeah.
just talking about because I just want to know that we have enough content here because this is important, right? Um,
Yeah.
the database side is one of the important parts of a engineer, especially one that's working. I like even for startups usually this is the most important because in the bigger companies they kind of abstract the database away from you a lot.
Yeah, that makes
But
sense. Yeah, I
um,
think like the database is like I mean, obviously like working in data, I'd
yeah.
say I'm probably better at that than the other stuff that they might ask.
But you're familiar with indexing and transactions.
Yeah,
Okay.
like forward keys, primary keys,
Yeah,
just basic index like indexes. And I mean, like a lot of the tables that we have, we put indexes on like the timestamps so that they're easier to query.
I see. Okay.
Because like the way we do ETL is like batch loading, so it's easier than like
Okay.
not having because like we're querying unmodified
All right.
timestamp.
That makes sense. Okay. How are you? How familiar are you with the infrastructure that hosts these databases, like
So
AWS or
like,
something like that?
I mean, yeah, we use AWS. I guess I'm not super familiar with, I guess, what's going on in the back end on their end. But like, I mean, basically, you just connect to the like you connect to the Postgres database with like the creds, and it just runs as like a relational database. I'm not sure exactly what you mean by the infra.
Yeah. Like okay. Are you familiar? Are you familiar with the different options on AWS or Google Cloud that we can run? Or pretend I'm like, okay, Paul, I want you to host our Postgres database. How are you gonna host this Postgres database? What are your
I
options
guess
here?
I guess I'm I guess I'm not familiar with that then. I
Okay.
know there's like I know we have Redshift and Postgres. I don't know. I don't think that answers your question though.
Yeah. So I think okay, well, let's write. You should get familiar with AWS and some of the options. So, for example, with AWS, there's RDS, which is a service. It's relational database service. Are you familiar with EC2 on AWS?
Yeah.
What's a EC2 instance?
I mean, it basically just like runs like a file system pretty
Yeah.
much just on AWS. I mean, you can like when I remember in my distributed systems class, we had like EC2 instances and we had like a map reduce thing that we wrote. It was used like I think it was 8 EC2 instances or maybe 4, and basically just having like a master slave architecture where it would
Yeah.
like have them run like through RPC
I see.
the the map reduce on different chunks of like the text.
Okay. So you're saying EC2 is just a file system, or
Uh, I mean, I'm not sure.
yeah. So EC2 is just a way to rent a server on AWS. So you can pick sizes of the server. It's like different servers with different sizes. So traditionally, like if I started a company, right, I have to, if I want to host a server, I spin up a server, I connect it to the internet, maybe I expose my IP address to the public, and now I have a server, right?
Yeah,
But with Amazon, you could just go on AWS and spin up your own server. You could choose the size, CPU, the RAM. That's what the EC2 service is allows you to do.
yeah. I mean, I guess I just didn't explain it well, but yeah, I kind of do that. Like
Yeah,
how to spin up an EC2. I
yeah,
just I don't think I explained it well.
yeah. Okay, so yeah, it's basically EC2 allows you to rent services. That's what AWS is essentially just doing, right? It's allowing you to rent servers on their cloud, right?
Yeah,
Every time, like when you spin up a Postgres database, what is it doing? It's spinning up a server. It's installing Postgres onto that server, and then exposing that IP address, and then allowing you to access that server using some credentials, right?
yeah,
Like with any service on AWS, essentially what you're doing is spinning up some server, downloading whatever software. It could be like Postgres, it could be like Dynamo, it could be like Mongo, right? Um, so yeah, I would say with AWS here, I would say in your resume you should get familiar with it and maybe do a project where you spin up some AWS instance and try to host Postgres on that AWS instance. That just shows like you kind of understand how the infra works, how to connect to it, how to set it up. You're familiar with the console.
Yeah, so I
Makes
could like I could just make like I guess what a project that would work on that would be like a website maybe.
Yeah. Take a small, build like a small, yeah. Any project where you host the whole thing on AWS. Like for AWS, you can use like the different services to. You can use like RDS. RDS is relational database service,
Yeah.
and in RDS you could choose the database you want. You could be like Postgres. You could use like MariaDB. You could use like MySQL. Um, but that's how you host relational databases in AWS. And what it does under the hood is essentially just spins up an EC2 instance and downloads whatever you choose, which is like Postgres, and then has that like a has like a Postgres daemon or whatever running on that server, and it stores all the files in there as well, like databases store stuff onto the file system, right?
Yeah.
So it just uses that whole EC2 instance or that server and runs everything there. Um, I mean, it's a bit smarter than that because there's other things like replication, um,
Yeah, for
master
sure.
slave, all that stuff. Like it handles that all under the hood. That's what they provide as a service. But um, yeah, I'll just get used to that, or like spin up, like have a project where you just spin up a random RDS server.
Yeah, makes sense.
Okay, how familiar are you with REST APIs?
I mean, I know like get post, but uh I forget that. I'd say what's the other one? Delete? Yeah, delete.
Yeah.
Like I know what they do. I don't really know how they work under the hood. I don't know if you need to know that.
How familiar are you with networking?
I just took a networking class, so I'd say like right now I'm probably like at the most familiar I can be with it.
Okay, so what are the things you know, like DNS, HTTP?
I mean, yeah, those are working on like the application layer. DNS basically just like it's kind of like I mean I know it doesn't actually function as a hash map, but it's basically just like a hash map of website URL to IP to access. Uh, HTTP is just like the routing protocol, and then I know that like I know how like the encapsulation of like packet headers works. Like going downstream to like network layer for I guess to transport layer first and then network layer, and how
Yeah.
like the demultiplexing works, all that
Yeah.
stuff.
I think for the case to just get into SWE, unless you're working for a networking company, I think just understanding HTTP. So that's the application. So I think we just need to understand the application level protocols.
Yeah, just like understand them probably like a bit more specifically.
So what are the different application layer protocols? Simple HTTP, I don't know, WebSockets, server-side events, like RPC. At a high level, you kind of need to understand those, especially if you want to get into more backend roles.
Mm-hmm.
So I think understanding HTTP, understanding WebSockets, server-side events, RPC, understanding application layer protocols, having a breadth. But I would say if you had to dive into one, just dive into REST APIs, REST principles, because that's just used everywhere. Like REST principles
Yeah.
are very common. So yeah, I would just have something in your resume that kind of signals you understand REST APIs, REST protocols, because that's how the front end is going to communicate with the back end, right? That's the entry point.
Yeah, I know like with my current role we work with the data API a lot, so I could probably like spin something up on that.
Okay, have this in your resume. So so we're just working backwards. So what web service, like, are you familiar with Django, Express? Like, what web application frameworks are you used to using? Do you have experience on?
I've used Django and Flask. I don't think people use Flask anymore. I've never used like any of the JS ones though, like the backend JS stuff. I'll probably do a project with that because I know that everyone uses that.
So you're more familiar with Python backends
Yeah, and like Go.
and Go. Okay. What did you use to Go? Like what
Like
application
that.
framework?
I just used it for a class, but like we made like a little mini website, and I could probably like get back up to speed with that.
Yeah. Okay.
But
And
I don't know how many companies actually use Go. Like I know it's good, but I don't think people have actually started using it really.
okay. So what I'm thinking here is okay. How familiar are you with like security portion,
Uh,
like
what do you mean by that? Like auth?
authentication, like OAuth, like authentication? Yeah, encryption, cryptography, things like that.
I know how to use like the what is it, like the Go auth, OAuth. I know how to use the API for that to like make a login for a website. I don't know like I don't know the specifics of how it works or anything like that though,
Okay.
or like how hackable that is.
Yeah, security is like I mean you'll learn that at the job. They have like
Yeah,
linters and stuff that could catch security vulnerabilities. But let me think about this. You see where we're getting here, right? Like I'm just trying to see where like the breadth of understanding you have,
yeah, I
because I
see
think
what you do.
this is all important stuff. Like if I want to hire you, I want to know, okay, can he? First off, I think where I would start is does the person know how to build APIs? Because when you're working backend roles, everything is you're gonna have to build APIs. Either it coming from a front end that's hitting your API, or it's like internal API to other teams.
Yeah,
Like building an interface for your service, your code is important. Everyone needs to kind of know this. Um, so I'll get an understanding. Like, do they have in their resume anything that could signal they built APIs? Because if I hire you and you don't know anything about APIs, it would be hard for me to know that you're gonna ramp up, especially on the job, fast enough.
yeah, that makes sense.
So I think having your resume, like first off, like that you built REST APIs and you understand some of the application layer protocols.
Yeah, that makes sense.
I think after that, once you build the application layer protocols, I think the next part that's in every job is having a database. So I think um, having in your resume that yeah, like you could build ABIs and then you could work on some of the other backend stuff like modeling the data, making sure the data is modeled correctly and queries are really fast, understanding just the theory behind databases like foreign keys, primary keys, indexing, SQL, NoSQL, just a breadth of knowledge there, then I could have confidence that if I give you a backend task, you can like persist the data good.
Yeah, yeah, I know. Definitely backend rules would be more. I don't think I'd do a front end rule. I'd rather just do data.
Yeah. Okay. And then like pretty good. Okay. And then after I know that you could build the API, you could model the data. Obviously, you know Python or whatever language you're working at. Then one thing that's important as well is them having familiarity with the infrastructure. Because if something goes wrong, maybe it pull you into on-call issue, and you don't know anything about AWS. Like it's
Yeah,
not the worst because it depends on how big the company is. But if it was a small company, that would be bad because I would expect you to be able to know under the like the the AWS stuff to debug because you might be the only person that we have bandwidth on to look at the question.
yeah,
There won't be
yeah. That makes
dedicated
sense.
infra teams. But so that's why I would say like I would prioritize on your resume REST APIs. I would prioritize like all the database stuff you mentioned. Then like a cherry on top would be understanding infrastructure. I think that would signal a really good candidate on the back end.
Yeah, yeah. I'd be shocked. I'd be shocked if people don't really have infra teams because like my company only has 200 people and we have an infra team, so it's like not like huge or anything. Do people like not have infra teams?
Like in my very first company, we did have an infra team, but we still needed to handle a lot of the infra ourselves. It's like
Yeah, I know. Like
yeah.
with my current role, we do like our own DevOps because the DevOps team just like doesn't do anything.
Yeah. See. Yeah, like we have an infra team. They kind of set it up, but like our on call issues, we don't want to keep pinging infra every single time there's issues. Like we need to be able to debug.
Yeah, I think I'll learn probably more about that because I haven't been on call yet. So like once I'm on call, I'll probably learn a little bit more about that stuff.
Yeah. Let's see. How familiar are you with the other parts of the ecosystems? Maybe like error logging and reporting, application performance monitoring, um, on call issues, and how those get triaged and notified.
Uh, I know we have like a lot of monitoring tools. I think we use what do we use? I think we use I don't remember what it's called. There's something weird. I've never heard of it. And then we have like PagerDuty for paging. But like in terms of triaging it, I'm not super sure on that.
For paging. How are exceptions and errors captured and then sent over PagerDuty?
Just check. I can just look at the Slack. There's like a Slack channel that has the PagerDuty stuff. I can just check it.
Because what I'll say is like, okay, yeah, like how do you figure out what goes in PagerDuty? Is someone manually putting things through PagerDuty, or you're getting?
No. It's like automatic error logging. I think it might be Datadog. I'm not super sure though.
Mm-hmm. Yeah. Do you know much about Datadog?
Not really.
Okay.
And then it's like used for like monitoring I guess server quality, and also you can use it for like timing stuff a lot.
Okay. So I'll talk about this. Okay, let me talk about this a little bit. So pretend I have a backend, right?
Yeah.
So I have a backend. That thing's running in production. I want to know when things go wrong in my code and alert the on-call engineer, right? So how would I do that? One very simple way, like pretend I wanted to build it all in-house, was that I can write my code with try and except blocks, and when an exception occurs in my code, I can build like an API that I can send errors to, right?
Yeah.
So it'd be like
Yeah,
you
that makes
catch
sense.
errors, and then you can like
Yeah,
post request the error to like some service, and then that service, we have a service that handles get receiving errors, and from there we can catch all exceptions in our code and post request to our error service or error handling service, and that error handling service could notify PagerDuty and then notify the on-call engineer. Like we can
yeah,
make sure
yeah,
that service, right? So there's a bunch of different softwares that essentially do that. You hook it into your code, and it has exception handling, and it sends it over. Like when exceptions are caught, it sends it over to PagerDuty. There's tools like Sentry is one of the biggest ones. I'm not sure if you heard of it.
I think Sentry, you said?
Yeah, look up Sentry. It's like an
I think
error.
that's actually what we use. That sounds really familiar because I know
Okay.
they were talking about like renewing the license for that.
Yeah. So Sentry, what you do is you connect it to your front end, you connect it to your back end, and it's like it's more complicated. But what I would just say is like you could think about it is it just hooks into your exception blocks and does
Yeah.
it
You
like
just
you
like
can
call the API or whatever.
yeah, like if you look at a front end app, look at the network tab, and you get to an error, you'll see that it literally is making a network post request to Sentry with like the stack trace of what went wrong, right?
Yeah.
And then it goes to Sentry, and in Sentry you have a nice view of all the errors and when they happen and stuff. They add value on top of that, but also they allow you to hook up into other third parties like PagerDuty to notify the on call. So that's kind of the process there of like how you catch things, right? Like you
Yeah.
could also catch things like by having like an email or like what's the old way of doing it is like, yo, if you have something wrong, just email this email and report the issue, right? That's like the
Yeah.
old
Yeah.
school way.
I think like whenever I think one thing that I don't really do is whenever like people ask me questions, I don't like if I don't know it super well, I just won't even answer like the basic stuff that I do know. So like whenever you just ask me that, like I do the basic stuff of like how like you just try accept blocks and it just calls like an API. I just didn't know like what the API was doing, so
Yeah.
I didn't like answer.
Mm. Makes sense.
So I
And
think like in
then
a real interview, I'd need to get better at doing that.
yeah. So essentially, what you do is it's like a library you just import into your code. It tries to be non-intrusive, where you just kind of import it, and then out of the box you get error handling, which is good.
Yeah,
So Datadog is a similar thing, but it handles performance related, like it captures latencies and stuff like that. It captures API calls, errors. Like it pretty much you can do anything in Datadog, but it's a lot of companies use it for performance monitoring.
yeah,
So
just to make sure the site's not slow or like the
exactly,
database isn't slow or
yeah,
something's not slow.
yeah, it captures everything. Um, you
Yeah,
it
we
can
have like
even
in-house
capture.
reports for a lot of that stuff. Like we have in-house performance reports, so it's really weird because we don't use like any of the normal software because we just have it all like in-house performance monitoring. If it like gets slow, it'll like it calls an error for us.
Yeah, and even with even with Datadog, right? You can set monitors and alerts, and that's a different way to trigger. It's not exceptions or anything, but we could say that we've seen like a spike in 500 requests, or we've seen latencies go up to like 500 milliseconds on
Mhm.
average. Like let's notify the on call. You could set up alerts like that as well, and that's more of like a on like a app or a performance monitoring, because yeah, it's important to have application monitoring. Is like when stuff actually breaks, when there's logic errors, when there's like code paths that you didn't expect, and there's exceptions. That's very important as well. Someone needs to go fix that. But then like on the meta level stuff, it's
Yeah.
like
I guess
when
the
is the
question I
slow?
have
Oh yeah, go ahead.
is like on the SUI level, is it like at least I guess it just in your companies, is it like abstracted away from you how to like distribute stuff, or is it like are you the one who's doing a lot of that?
We have to do it. It's like
Okay.
if I own a backend, I need to have complete ownership of it. I need to first out build all of the logic. I have to build all the logic that to make sure that the business requirements are met. And then while it's functioning, I need to make sure that like it's scaling well. How do I know it's scaling well? Like it's performing well. Like the queries are happening faster. If it's not scaling well, things are gonna start breaking, and I need to be able to fix that. I need to find and catch errors when it happens. So I need to know when the database is in a bad state, when errors like you just need to make sure that thing that you own is working end to end, and you have complete ownership of it. If that makes sense.
Yeah, say like you need to like parallelize something, I guess how would you go about that type of scaling? Like don't you just have to like request for more servers in order to like
Well,
in
like
order
there's
to scale something like that?
well, it all depends on the issue, right? So
Yeah.
pretend the you've seen spikes in the response times, right? That you're handling. Like, what are the different ways you can debug that response time? Like, okay, let's analyze. First off, I'll look at the queries. What is that query? Maybe we weren't indexing it, like very fast stuff, right? Like,
Yeah.
is the query could we have indexed it to go faster? I mean, like that simple stuff. It's like, but then should you even add a query there, or should you update the query to make it better, right?
Yeah, that
Like
makes sense.
change the query patterns, the access patterns. You think of different ways like that, right? Um, yeah, like can you change the application layer, anything to just you just have to figure out yourself. But I think the most important part is being able to know when that is happening in your system, and that's why I'm asking you all this monitoring stuff. It's like
Yeah.
you'll never know to optimize your database if you never get alerted on it, or you don't set up
Yeah,
process.
there's no like graphing or like any way to see the performance.
Yeah, and then like with Datadog, you can see, oh, this is the exact query, or this is the API endpoint. Pretend there's a get request. Pretend we're on Facebook. It's like there's a get news feed, and that's spiking to like 5 milliseconds or 5 seconds. Sorry, that's right. I'm seeing that spiking on Datadog. Then what I would do is I'd use the different tools to debug what's happening. First, I'll look at the code. I'll be like, what's actually happening here? What's the query happening? And debugging the code there. Then yeah, I'll look at the queries, and I'll use different tools that we have in order to dive deeper into it. Like if I need to run like a flame graph, or I need to run like a query analyzer, there's ways to run that as well, and just see what's slowing it down. Like Postgres query analyzer will literally tell you where the full table scans are happening and stuff, and you could just like index that if you need. But
Yeah, that makes sense.
I think, yeah. You have any questions for me?
Uh, I think you answered most of them. I think like the main things I need to focus on, just to I guess double back, is like get a little bit more familiar with like application layer protocols, and then I guess I'd say I'm pretty like good with the DB stuff, just more of the inference side of the DB stuff. Um, and then was there anything else that you said it's like the main thing I should like work on? I guess I should just make like a project probably and like make like a website.
Yeah, I see. Yeah. First, I'll just say at a high level, make sure your resume kind of encapsulates all of these. And Chad, keep me honest if there's like anything I missed here that is we should add that will make him more hireable too. Because what we need to do here is make sure that your resume like encapsulates everything. Oh, testing and testing and stuff. Yeah. How familiar are you with testing, building out test suites and stuff?
Uh, I mean, data test cases are really easy to make because like if your query just doesn't return the right stuff, it's wrong. I guess in terms of like web dev stuff, I'd say probably similar. Just if it doesn't return the same stuff, the correct stuff, and then also like just like pure end-to-end test casing, I'd imagine would be
Yeah.
important.
Yeah. So understanding the different end-to-end testing, end-to-end unit integration. So I think when it comes to backend, right? So unit
Yeah.
testing is probably the easiest testing. You just test the function.
Yeah.
But those are two, like when you're working on a backend system, you're gonna be doing more integration tests as well. So for example, how do I test a API? Do I want to unit test the different functions? Or do I want to actually make API calls to my database? Or like in the test case, spin up API and make API calls against that API.
Yeah, probably just call like the APIs on it because if you're
Exactly.
just testing the functions, you don't know if the API is actually working.
Exactly. So build a program where you have a test case that spins up your data, or usually you mock out the database stuff, but I mean you could do this in multiple different ways. But I think integration test is really important for backend developers. Then end-to-end test is more important for full stack developers because you need to spin up the front end and talking to the back end. But
Yeah, I know like whenever like on the ML project, they didn't really have anything set up for the backend itself, so I was having to spin up the front end to test anything.
okay, so yeah, you understand your testing. Understand. Okay, people are talking about this right now. Basic knowledge of CI/CD. Yeah, I think that's important.
Yeah, I know Docker and CI/CD, like Jenkins and stuff.
Do you know Git?
Kubernetes, Git.
Yeah.
Yeah.
Probably know it, right? Yeah. Okay, no Git.
Yeah.
No version control.
Yeah, I think I'd be shocked if anyone like doesn't use Git that much.
Yeah. So yeah, I think. So let's talk about this. Let's just recap. We just need to make sure your resume encapsulates all this. I'll send you all these notes. Like,
Yeah.
I'll actually send it to you on Discord, but I'll send it after this. But make sure you're. And I'll post this a different video too if you want to do it. But yeah, I would just iterate on your resume a bit and make sure you have. What I would prefer is work experience that shows that you know these things. If you don't have work
Yeah.
experience, fill it in with projects.
Yeah. I mean, honestly, I get keep me honest here, but can I not just like lie on that resume about work? Because like they're not gonna call my work and ask if I did this particular project.
Yeah.
They're just
Yeah.
gonna call and see if I like work there.
Yeah. And then what I'm gonna say too is like this will just get you a basic resume, and then will get you probably some roles. But I think at a better case, you have projects. You build projects that encapsulates all of these end to end, and this shows that you could do this. right? So it's not just
Yeah.
like, instead of just listing out the job description, you're listing out projects that you did. So for example, maybe like I built out this API end to end, right? And this API did X, right? That shows that you kind of like know these from end to end instead of just listing them out, right? Or you say, I improved the query performance from like 400 milliseconds to 20 milliseconds and like move this metric in the company, right? That shows that you understand database optimizations without just saying like, yeah, I did it, right? Like you actually have an example
Yeah.
of you doing it. So I would say let's build a resume where you can kind of show that you get these different skills. Then afterwards, let's find projects that are good, that have good bullet points that could show off these even better, and that you could actually talk about in an interview. Because if you just say,
Yeah, that
yeah, I'm
makes sense.
familiar, if you just say I'm familiar with Postgres optimizing, right? I'll be like,
Mhm.
okay, what? Just tell me a time when you actually have to do that.
Yeah. Yeah, that makes sense.
Yeah. So all the tell me about the time should be on your resume, kind of things. Like, I did X, Y, and Z, right? Like it should be results oriented, the resume.
Yeah.
Because
Yeah,
this list,
I'll try rewriting my resume and send it over and see what you think.
nice, cool, yeah. Because this, if we just built your resume based on what we talked here, it would just talk. It would just be re-listing out the job description.
Yeah,
Yeah,
it makes sense.
cool. All right, hope
But
that
you
was
want to like the
helpful.
projects on there as well, not just the job description.
Yeah, like you don't want to relist out the job description in your resume. You want to talk about the results that you drove at your company that align with the job description, because they people hire based on behaviors, right? Like
Yeah.
if you optimize a crap ton of like queries at your last company, you already have shown that this is the stuff that you do when you work at the company. I'll be like, I want to hire this guy so he can optimize my stuff. Right?
Yeah. Yeah, I might ask like my boss if I can work on some of like the back end projects just to see, because I'm pretty sure like he's like the manager of the SUI team as well, so I could probably just ask him and he'd let me do like some stuff on the side.
Yeah. So what I also, one thing too is look at this. Maybe like, oh, I have gaps here. Let me talk to my manager and try to find opportunities where I could learn this stuff, so I can have it on my resume and I can have projects on it about it.
Yeah, that's what I'm thinking too.
Yeah.
It was a good chat though.
Yeah,
Thank
that
you.
was good. Cool. All right. Talk to you later, man. Let me know if you have
Yeah,
questions. All right.
yeah, sure.
Peace.
Peace.
Yo, chat. Okay, we're gonna get back into coding. That was a good chat. Raccoon, what's the conversation about? We're just talking about career, doing algos and stuff. That's what the stream is about. I'm gonna do more algos right now. Who wants a coding interview? Drop it in the chat. Oh, Raccoon, you want one today? Yo, message me. Yeah, Raccoon, we can get you on there for sure. Oh yeah, we can do that too. We can do that too. Yo, Alpha, I'm gonna send you a new meeting link. Let's do. Um, Yo, Alpha, I'm gonna take a 10-minute break to rest up, but I sent you a meeting link. And you want? Are you good to hop on in 15 minutes? Okay, six. Okay, I'm gonna put some time on. Put quick goon break. Hey everyone. So today I have Daniel on the chat or on the live stream. He's a University of Waterloo student. Could you just give a quick background on? You go to University of Waterloo. Like, what year are you in? What companies have you worked
Sure.
for? Maybe what companies are you aiming to try to get into when you graduate?
Sure, yeah. Hey everyone, my name is Daniel. I'm a third year software engineering student at the University of Waterloo. I've completed around 180 leak code problems. I'm going to be interning at Stripe this summer,
Nice.
and in the future, I'm looking to kind of break into more big tech roles. So, kind of just trying to get some practice in through mock interviews.
Nice. Yeah, Stripe is a really good private company. Are you trying to break into like fan companies too, or you want to stay at like Stripe level companies?
I think like I've worked at like Stripe is gonna be my second unicorn, and
I
then
see.
I have something lined up for fall as well. So that's gonna be my third unicorn.
Wow.
Hopefully, I kind of want to try out like working in big tech as well. So yeah, definitely try to transition into Fang at some point.
What's your next unicorn, if you don't mind sharing?
It's gonna be Verkada.
Oh, nice. The camera company.
Yeah, yeah.
Are you gonna be moving to the States at all, or it's all like in Waterloo?
So Stripe is in Toronto, and then for Verkada, that's gonna be in San Mateo.
Cool. So, what do you think your leak code skills are at right now compared to maybe your
I think
peers?
I think my LeetCode skills are like average. Like I've done LeetCode style interviews before, and I think I've like held up decently. But for most of my like interviews at unicorn companies, they weren't really LeetCode style, so I kind of want to prepare myself for more like big tech
I
interviews.
see. I see. Okay. I see. Okay, we're gonna get to the first questions then. It's like let me pull up. So how we're gonna structure this interview is pretty much we're gonna ask you two questions. You have about 20 minutes. 20 minutes for each question. We're gonna try to keep it around 45 minutes for the whole interview, and yeah, like when we hit about the 20-minute mark for the first question, we're gonna move on to the second question. Just yeah, don't mind if I interrupt
Sounds
and we
good.
move on to the next question. I'll give you feedback at the end to see where you're at and let you know where you're at. Um, okay. So I'm gonna post the first question in here.
Okay.
So, yeah, I'll let you go ahead and read this question and clarify every like all the requirements and stuff.
Okay. I'm just gonna take a minute to read through the problem.
Go ahead.
Cool. Okay, so after reading the problem, it seems like we have an integer array of n buildings, and then each building is, or the value at index I indicates the height of the building, and then we're gonna have an ocean to the right of this list, and we basically want to output um, a sorted or like in order what buildings have an ocean view.
Yeah, exactly.
Um, just to clarify, like if two buildings are the same height, then the one that's comes before on the left wouldn't have like a view, right?
Yeah, exactly. Like if a building is just as tall as you, you're not gonna see anything, right? You have to be taller than it at least.
Yeah, okay, cool. So I think off rip, my initial thought is wait, hold on. if we have like a building of height, is it possible to have a building of height 0?
No, every building
Okay.
is one or more. 0 means it's no building there. But let's say every
Yeah,
building
okay.
is at least one story.
Got you. So I think like what comes to mind initially is we can just start from the back and then iterate to the front of the array, and then we can maintain like the highest building we have so far. And
Okay.
then if we have a building that exceeds the height of the previously highest building, then we can just say that yes, this building has a view of the ocean. We can store it in our solution array.
Hmm.
Um, and then we can update like the variable that keeps track of the highest building we've seen so far. And then I guess we're just adding these indices in order to an array. And this would also keep it in like a sorted order, so we can just return from there.
Okay. Can you wait?
Would you
Can
like
you
me to go
walk?
through like a?
Yeah, walk me through a small example here of like.
Sure, I'll just go through the first example.
Yeah.
So basically, we have like some ocean, which is like here,
Sure.
and then we have like some buildings of certain heights here. So if we're gonna walk through this input, then we basically have like one obviously can see the ocean because previously we have maybe like a beach that's height 0.
Yeah.
So we would have like 0, 1, 2, 3, and then 3 is higher than 1, so 3 also has a view in the ocean. So we also have 2 here, and then 2 doesn't exceed the highest height we have so far, which is 3. So 2 would not be added to our solution. But then when we move to the last element in our input array, we have 4, which exceeds the maximum height so far of 3. So we would have to add this index as well to our solution. So the answer would be 0, 2, 3, which are the 3 buildings that can see the ocean, and these are also sorted by increasing or in increasing order by indices. So I think I'll type my. I'm gonna begin. Does this approach make sense?
Yep, that makes sense.
Okay, so I'll just type this out kind of decode style.
Sure.
Solution def. We'll say like find ocean view, and then we'll do as well as I guess yeah, that's all we're taking in. So can do like a for loop, or we can initialize to our max height. We're gonna initialize to 0, and this is basically gonna hold like the max height of a building we've seen from the right. And then we can iterate backwards. So we'll do like for ind x or height in enumerate buildings. We'll do like we'll have this reversed. So we'll do if the height exceeds our max height. If the height exceeds our max height, then we can add the indice of this building to our solution array. So we have to define like a resulting array. Do res.append ind, and then we'll do max height equals height. And then let's see, what order would this return? What would our results array look like after this? Just put this here for now. If we go through backwards, the indices are going to be reversed, so I guess we have to account for that. So we'll do like
What does this do? Does this create a copy of the buildings and actually reverses it?
Yeah. I think we could also in Python, there's like you can use like the reverse keyword, but I don't know. This is the way I know how to do it. Like this just creates a copy in reverse order.
I see.
So
So like, why not just use an index and go backwards? Have an index.
yeah, that's true. You're right.
Yeah.
We can do like in range
Because if it's like
n,
a
and
massive
then
array, it's like I feel like it's a bad way to revert, like go backwards on an array.
yeah, if we make an entire copy, right? So yeah, that's true. So we'll just do like buildings, n minus minus one. All right, so instead we're gonna iterate backwards using an index, and we basically just compute like where the matching index is at the back of the array, and then we want to append this and not the actual index. We can access our height using this, and then if the building exceeds our max height, then we should append this index and then set our new max height to this height. But what order are we appending our indexes in? We have to return like our resulting array in reverse order, I guess, since we're going from the back to the front and we're appending. Yeah.
Sure.
I guess like this is not, it's not clean to like make a copy, but like I think it's like O of n to just insert into the front of an array.
Yo, Alpha, I sent you a new. Sorry. Alpha, I sent you a new Google Meets. Who's calling me? Centroid decomposition was that? What is that? What's centroid decomposition? Raccoon, how's my audio, by the way? Alright, let's finally get Alpha back in the building. Alpha, let's go. Good as always, nice. Admit Alpha. Alpha, what's up, man?
Hey, is my
How's it
mic
going?
working?
Yeah, your mic is working, but it's a little low.
Little low? Okay, interesting. Don't know if I can make it higher.
Oh no, I think
Let's
it's
see
better
what's-
now. Chat, you tell me, keep me honest. How does it sound, Raccoon?
Okay.
In case you say something, be like test, test, test.
Test. Yeah, cool.
Okay.
Alright, seems fine.
Alright, cool. Ollie, you had some questions, right? I said I was gonna send you some links. Yo, Alpha, are you ever gonna teach some algorithms on your channel, like the series I was doing, or just do questions? Or did you already do that?
I might do that in the future. Yeah, like coding patterns or something, or like people ask like, how do you know if it's DP or that kind of stuff? Yeah.
Yeah, like those hypothetical or like those situational stuff, or I mean not situational, but like theoretical tutorials. and
Yeah.
stuff.
Yeah, I might do that. No, right now I've just been doing the like the 0 track 2K plus difficulty problems,
Yeah,
trying to
that's
get
sick. I
to
like
all
that
of
one.
those. So yeah. Trying to get to I think I have about half of them done. So it'd be kind of interesting once I get to the like 3K and stuff.
Yeah, that's gonna be really interesting. So
Alright.
Ali, quick. I'm just gonna send him links quick. I have this algorithms playlist where I talk about the top 6 coding patterns for coding interviews. So if you already know the coding patterns, just go ahead and, or you already know data structures, work on that. But coding pattern series. But then, Alpha, you had a good video on this too. Let me send yours, Alpha. The one that you
For
pinned on
which
your,
one? Like what to learn and stuff?
like how to get good at leak code kind of thing.
Oh yeah, the intro one I have is like pretty good. It's for more like beginners, but yeah. So like if you don't know if you need a roadmap.
Yeah, this roadmap is good.
There's the. Did I just?
Yeah.
Leak code. Let's get it.
Alright.
Cool. And then, sorry, I'm gonna send one more thing. I have this other playlist, how to get good at leak code. So Ali, I did like a bunch of videos on this. So I talk about array theory, arrays from scratch, linked lists from scratch, stacks, queues, all that stuff, trees. I'm gonna continue this series. I'll send you this, and I have a video as well on how to get good at leak code. How many questions? 650 or 647, something like that. Let me check. All right, I'm gonna spin up a video.
All right.
644. Okay. Oh shoot, I've been recording this whole time. All right, 3, 2, 1. Hey everyone, so today I have my friend Alpha again, and he's gonna be putting me through another coding interview. So Alpha, do you want to quickly talk about what kind of coding interview you're gonna put me through today? Maybe what we might focus on. I mean, you don't have to make it super specific to DP. I think just generally just want to keep practicing lead code. So these mock interviews is help keeping me a bit sharp too.
Yeah, so I've been doing like the 2K plus problems. So I'm just gonna give you some of those. I have some easy ones, some harder ones, depending on how you do.
2K
And
ELO?
2K ELO. So we'll see how it goes. A lot of them I think are pretty straightforward. Some of them are kind of hard. So we're gonna start with like an easier one, and then yeah, depending on how you do. I have 4. And then we'll just kind of see how you do. If you do the first one super fast, I'll ask you a harder one, things like that.
Well, you see my ELO right here is 1500.
Yeah, I gotta bump that up, dude.
All right, let's try it out.
All right. Plus, like people have been saying, you get better by being challenged, So if you just keep doing like binary tree traversal or something, never.
You're right. This is what I need. This is what I need.
All right. So we'll start off with this one. Oh, actually, I can add you to the actual problem.
Yeah, add me. Just send the link. Everyone, go subscribe to Alpha. He's been dropping sick content.
Wait, let me create a link. You can only join. Okay, for some reason I can't.
Hello and welcome to another.
Why? Let me see. Oh, it's because I'm in one. Okay.
People
Yeah, they have this really dumb thing on here where like it doesn't just like auto kick you out of a join. Like when you're done, even if you close a tab or anything, it's kind of annoying. Okay, I got it. So can you
ramp up my ELO? That's crazy.
You gotta ramp it up, dude.
Hards. That's crazy. Okay.
Yeah, so all these are mediums and hards.
What's the ELO of this one? Like just flat 2000?
Oh, so there's another thing I found. It's actually a Chrome extension. It's called Leak Code Difficulty Rating. And if you get it, instead of like the medium or whatever, it'll actually give you the rating. So I think it's really nice to start using it.
Wait, I'm going to send you a room link. For some reason, it tweaked out when I used mine.
Okay, that's fine. But yeah, I would recommend getting that sometime in the future. Because yeah, literally like instead of the hard or whatever, it actually has a rating. So it's kind of convenient.
And it like uses 0 track to figure out the rating, or does its own?
I think so, yeah, because it says 2008 for this one. Yeah.
Okay, awesome. All right, okay, is this a math one? Because I cannot do math one.
It's not a math. You don't need any math. I mean, there might be some math thing, but it's not required.
All right. Okay. So we're taking on some 2000 ELO questions.
Yeah.
All right. Let me parse the question. So a die simulator generates a random number from 1 to 6 for each roll. You introduce a constraint to the generator such that it cannot roll the number I more than roll max consecutive times. Given an array of integers roll max and an integer n, return the number of distinct sequences that can be obtained with exactly n rolls. Since the answer may be too large, return it modulo 10 to 9. Two sequences are considered different if at least one element differs from each other. Okay, so let me take some notes here.
Yep.
We're given we're doing a die simulator, and we're building a die simulator, and we need to. I mean, the die has what you can roll 1 to 6. Roll 1 to 6. We're given a roll max, so and the roll max is 1, 2, 3, 4, 5. The roll max is 6 elements. 6 elements, and I'm guessing it's like indexed based on, like, we could only roll for this. So if roll max is this, right? That means we could only roll one time, one consecutive time, right?
Yeah, consecutive. Yep.
So we need to see the different number of sequences with exactly n rolls. So we're given n rolls. So what are the different ways we can roll to? We're given n. We're given what's the number of ways we can roll n times. So I'm thinking it's like, okay, let's assume maybe we could roll 1, and then we can only roll 1 once, so maybe roll 2. That's 1. So that's one unique way. Is this? Now I'm just checking. Does this matter? Like, does the permutation matter? I guess it matters, or just answer. Oh, because we're talking about sequences, so the permutation probably matters, right?
Yeah, so you can look at the examples, like especially example 1, and it'll make it kind of clear what that should be.
There will be 2 rolls of the die if there are no constraints on the die. There are 6 by 6 possible ways. Yeah. So in this case, looking at roll max, the number 1 appears at most once consecutively, and therefore sequence 1, 1 and 2, 1 cannot occur, or 1, 1 and 2, 2 cannot occur. So the final answer is, okay, you kind of remove that. There'll be 2 rolls of the die. 36 minus 2. Well, let me see. Oh yeah, because you could roll these 2 and you could roll these 2.
Mm-hmm.
So these don't really matter. Like if it was, yeah, there's no constraints there. Okay. Let me think. I mean, one way I'm thinking is straight up just brute force it. Like a backtracking algorithm where we try the different rolls. So like.
So what do you think would be the time complexity of a brute force backtrack? Just try everything.
Well, what is n? N is 5,000.
Yeah, n can be 5,000.
I think it's limited to the branching. We could only use 6, and there's a roll max. It could lead to an exponential algorithm, but there might.
Right, like let's say roll max is like let's say n's like 5,000 and roll max is like 15. We're gonna get really big numbers. So
yeah, it's already.
Can we do better than like a backtracking?
Yeah, like the first thing came with brute force, but maybe we can either brute force, or I mean we could probably use like a there might be a way to cache the results of the brute force.
Yeah.
And do some sort of DP. And then like maybe there's even some math solution that I can't think of right now that might be able to just calculate them, because in the explanation here they're literally just doing math in order to figure out. So these are the different ways I'm thinking. Cache result of the brute force, basically a DP top down, and then worst case, even this DP top down could involve math to calculate, or just straight up just some math solution that's not coming to me right now. So
yeah, so we can eliminate the math solution. There might be one, I don't know. We can eliminate the brute force as well because it's too slow. So can we do some kind of caching, DP, or some kind of thing like that? Yeah.
okay, so what we can do is, I mean, what are the different, let me think of like how the DP, so in order to come up with a DP algorithm, I kind of need to look at how the brute force plays out and see where I can cache. It's kind of the way I approach it, because the brute force would be top down with no caching, right? So what I'm thinking is we start with the empty list kind of thing, or the different options, and we're gonna build it to the leaf nodes. The base case is we've made 6 choices. Let's
6 choices
or n choices.
Oh yeah, okay, yeah.
So the base case is we made n choices, and is there ever a case that we can't ever make n choices?
Oh, what do you
We
think?
ran out. I think there's a case where the constraints are too low that we couldn't even make n choices. But
So how would that look? Yeah.
I would
Can you give me an
say,
example?
so maybe we had to roll 5 times or 10 times, and the roll max was like 1 for each.
Yeah, so the roll max is max you can roll consecutively, not like the total rolls you have of that number.
Okay. Oh
So
yeah.
there's a
Oh. Okay, that complicates everything, or trips me out a little bit.
It actually makes it easier once you figure out like how it works. It makes things easier.
You can.
So yeah, you can roll infinite of every number. You just can't hit the
Okay.
max at any point.
But just not the max at any point.
Yeah. And so do you see now how you couldn't run out of numbers because you could just like pick another one?
Yeah. So what I could do is for each one is gonna branch out in the brute force, right? It'll branch out probably 6 different times, where you're picking like 1, 2, 3, 4, 5, 6, right? But not only are we branching 6 times, maybe we'll branch out. Maybe like I'll roll once, or I'll roll twice, or I'll roll 0, or for each branch, pretend I'm gonna roll 1 here. I'm gonna roll 1 like once.
Okay.
And I'm gonna try, or like, yeah, basically you'll try roll 1 once, or 2, or 1 twice, up to the max, right?
Okay.
And it'll branch out that many times per roll. I mean per like dice, like 1 to 6. We basically loop through 1 to 6 in that branch. And then we'll pretty much, like, the depth of this will be like, we'll go until the base case, which is n equals 6 kind of thing, or we'll the depth of the tree will be n. But yeah, that's what I'm thinking. Like, kind of, we loop through each options from 1 to 6 on each level. And then we need to pass down like some like we need to pass down who we can't use, I guess. Because once I use 1 once, I'm gonna assume that I'm gonna do 2 or 3 or 4 or 5, like 2s or 3, like everyone but 1 on the next level. But if I choose like 2 once here, I'm gonna do everything but 2. But that might mess up our caching. So
so ideally we want to like cache as much as possible. So if we if we do what you said, where we try to roll like one once, one twice, whatever, like let's say all these roll maxes are 15, you're gonna have a lot of branches there from like one state. Like you might roll 15 different amounts for every single number, which is like, like 100 or something. So can we do it in some other way where we don't roll that many times, but then cache? Like, oh yeah, I guess let's ask like what's the minimum? Like this is always how it is for these DPs. What's the minimum amount of information we need to store to make a decision?
Yeah, I think we just need to multiply it, right? We just need to know how many options I have here. So I can roll 1, 6. Let me think. I think maybe we can. Oh, sorry. Could you repeat that?
Yeah, so in our like DP, we're gonna have some state like that we're storing and passing down. So what's the minimum amount of information we need to know to know where we are and like what decisions are possible? Like what's the minimum? Because the more information you store, the like
Less
worse
cacheable,
caching
right?
is.
Yeah.
Yeah, kind of like an extreme example. Imagine you're storing your location and like a lat long, and I store it exactly, then it would be kind of useless to store those things because it will be like so many combinations and decimals and stuff. It wouldn't be the best. So how can we like store the minimum amount of information we can while still being able to make a decision from that?
Yeah, each one I kind of need to know like how many, because what we can do is if each branch is already a roll. Oh, actually, we can't just do like 6 rolls in a row. We can't just do that because it needs to, like, each branch, if we want to branch up into n, each branch needs to make one decision. So I think we need to know number of rolls left
Okay, makes sense.
for each.
So when you say for each, can you clarify that?
For each dice. So we essentially need to pass roll max down with -1 based on the last decision we made.
Yeah, so let's say we're on
Or
like
actually, or yeah, go ahead, sorry.
yeah, I was gonna say like so for each die, we're only concerned about like not hitting this consecutive streak. So if we're on like number 1, we know we can roll everything other than number 1 as much as we want. Like we don't need that information, right? Does that make sense?
Wait, sorry, could you repeat that?
Yeah, so let's say we rolled like a 1 previously. We don't really need to know how many rolls we have, like how many rolls we did for any other number, any other thing other than what we rolled before. Because we're only concerned about not hitting this consecutive limit. So if we know we rolled a 1, we know like everything else is just going to be fine. So we don't need to have like every roll left for every number, if that makes sense. Because basically the only time we can't make a roll is like if we rolled that previous number, the roll max amount of times. Does that make sense?
Yeah, but like, how do we know? Pretend we're what I'm trying to think about right now is like when we're deep in the branch, and then we roll a 1. How do I know that I hit my roll max now? So that's what
exactly. So what's the minimal amount of information you need to store? So you did point out like I need to, yeah, like what's the minimal amount of information you need to store to know if you hit your roll max or not?
That's what I was thinking. Like, because when we're in a specific branch or a specific node in this like decision tree, we could be either making this decision for 1 or 2 or 3 or 4, right? So I'm thinking that's why we kind of need to know the rolls for every single one, and just maintain like how much we have left for each one. Like we have like 1 roll left for 1, 0 for 2. But I guess
so how can we have that state? Like let's say for example 1, you have this roll max array. No matter what you rolled, only one of these numbers will be different than the roll max array, right? Like if I rolled a 1 before, the roll max changes, but all the rest are the same. If I rolled a 2 before, the roll max for the 2 changes. Like you don't need the whole array. You just need to know like what's the number you're concerned with hitting your streak for, because everything else won't change, right? Like anytime I roll another number, the roll max resets for the rest of them. Does that make sense?
Oh shoot, I didn't even realize that. Yeah, every time I roll, I forgot about that. Every time a roll max, or every time we roll, we reset the max for all of them. So what I'm
Right.
thinking is like, so I think all we need to do is pass down the roll max. After we roll the roll max, we just pass down into the DP function. We pass down in our DP. We pass down obviously well in the DP we loop from 1 to n.
Mm-hmm. So when you say 1 to n, do you mean like 1 to 6 or 1
sorry,
to
1 to
n?
6,
Okay, yeah, okay.
We loop to 1 to 6, and then we probably pass like a variable gets passed down. That's just max rolls, or like rolls left,
Mm-hmm.
or yeah, rolls left. It's
So
like,
what does this rolls like mean?
like how many
what is
rolls
this?
left for
How many rolls do we have left for total or for the current number we're on?
maybe the current number we're on. So
Okay.
current number. So we need to pass down who happened before, which is probably 1.
Mm-hmm.
And then
Okay.
we'll be like rolls left is like maybe we subtract 1, we pass it in. So when we
Mm-hmm.
call DP, we'll pass in maybe the current number, which would be like the last choice,
Mm-hmm.
and then the rolls left,
Mm-hmm.
right? And then like when we DP into another option, then we kind of just cache on the current number and the rolls left. I don't know if that would work.
Mm-hmm.
Does it kind of make
So
sense?
how do we know when we hit our base case? Like on line 25, you said base case when I made n choices.
I think we just need to just keep track of like an options, or we just need to pass in like the path length. It's like if the path length equals n,
Mm-hmm.
and we just return like 1, because that's like one unique way to get down.
Right.
And then when we do the DP, it's like a for loop, and we're just adding up all the possible ones.
Mm-hmm. Mm-hmm. And then what would be the? Yeah. So we're caching on these 3 things. So what's the time complexity of the full function? So we have these 3 things, and we're looping through 1 through 6. So can you estimate the time complexity of this full function before we start writing code?
Let's see. Well, the branching factor is 6. Like if we didn't cache, it'd be like 6 to the n, or wait, 6, yeah. It's like the brute force would be like of 6 to the n. It's like now we're kind of caching, so it might be like O of n times 6. Wait, let's see. If we like, I still don't really understand, because what I would do is like, I don't know how many problems are actually overlapping that it's actually going to cache on. Because if you know how many overlapping problems it's going to be,
let's say we can have like all of these things. Let's just say, to make it simpler, all of these states can have every single number. Like let's say that's the case. All right. So current number can be anything. Rolls left can be anything. Path length can be anything.
yeah, okay.
So let's just say, like, what's the worst case time complexity
Yeah,
here?
I guess it's like n times like m, which is like the max of rolls max, like the maximum value there,
Yep.
times like 6.
Mm-hmm.
Leads to like an n times m algorithm.
Yeah. Yeah. And then we also have this part in the, so typically the way to calculate it is all of your states, assuming worst case, all of them can happen, times whatever's in your function. So because we have another 6, like we're picking 1 through 6 die, it would be like this.
Wait, we have
Does
to
that make
multiply
sense?
by another 6?
Yeah. Because we have 3 states here, right? So current number is 1 through 6. Rolls left is max, like you said. path length is n, and then in the actual DP, you can also pick any one of 6 die, right?
Yeah. Okay.
Okay.
So what I'm thinking is, so we're gonna be doing we're caching on all 3 of these, so it's gonna be like a 3D sort of DP. Because yeah, path length kind of matters because, like, if I already have, if we're only at 5, we only have one choice left to get to n. Like the number of paths can change, so we have to.
Yeah, like if we don't have the path length, we never know when to stop. We'll just keep going infinitely.
Yeah.
So.
And we need to include that into our DP cache, because in order to include it in our DP cache, or in order to actually cache results, like we need the path length to return the unique numbers properly.
Yeah, and so a quick trick you can use, I don't know if you're familiar with this, so you can do this estimation, then you can look at your constraints, and I think you need it to be below like 10 to the 8th roughly to paths. So if it's like rough, so like here n is like 5k, so that's like 10 cubed or something. M is 15, so that's another like 10, so this is like 10 to the 4th, and then these are both roughly 10, so you get like 10 to the 6th. So you can make these estimations when you have actual like OAs or problems, and then you can figure out like, will this TLE or not.
Awesome.
And it's kind of nice because you might make your estimation, and then you can immediately say like, oh, this will just be too slow. I can't do this. Let me try something else.
Yeah.
Doesn't really work for like an actual like on-site, but for OAs or any kind of that, you can quickly get a rough idea.
Yeah. Cool.
Okay. So
I'll go
let's
ahead and
try
implement
to.
that. Holy crap, that was actually difficult.
Yeah. Okay. Yeah, I mean the main, like, the way DP's problems get harder is A, you have to do a bunch of stuff before, or B, the dimensions are really tricky. So this one's like not super straightforward. Like it wasn't just like, oh, I just have like an index and then like how many steps left there or something.
Yeah.
So, yeah.
Rows left. So I'm gonna create this DP helper function. And I'm gonna build like I'll have a cache, which is a set. Then I'm gonna be like return self dot. Well, we'll just do the DP here, and the current number is probably none. Wait, let's see this. Because I'm trying to figure out the first one where we didn't. Okay, actually, the first number we'll just start with 1. We'll just say 1, and we'll just say the rows left. We won't actually reduce 1. Rows left with like the 0th index, and we say the length is 0, and then we just pass in like this cache.
Okay. Yeah.
And then let's just handle the base cases, like if the path length, and then we're gonna have to pass in n here. If the path length is equal to n, we return 1, because that kind of means like, yeah, that's like 1 path all the way down. And then we're gonna have like some result here, and we'll return the result, right?
Yeah.
And then here we're gonna have to do sort of the DP portion, which is looping through all of the options. So for the dice, in range 1 to 7, so we roll 1 to 6. What we're gonna do is for dice is 6. What we're gonna do is result plus equals self dot, or we're gonna say if the current number is equal to that dice and rolls left equal to 0, we're going to continue. That means we're at that current dice. That's the last one that we chose, and we don't want to do it, right? Okay.
Yeah, that makes sense.
Then we call self.dp, and then we're going to do this dice. It's like choosing this dice, and we do rolls left at that dice. And then we do that grabs the current number, the rolls left, what's the okay?
Path length is how many rolls you have total. So,
Yeah. So we're gonna do path length plus 1, and then we're gonna do n,
Mm-hmm.
right? And then we just do. We need to pass in our cache, which is gonna be current number, rolls left, path length. Okay, cache here. So what we can do is like it's a 3D DP.
Mm-hmm.
Where we store the current number, the rolls left, the path length.
Mm-hmm.
So we store that, and we just store the result. All right, that caches it. Now we do if this tuple is in our cache. It's in our cache. We return something like this.
Yeah, the nice thing about Python is like having more dimensions doesn't make it hard. You just add like another variable to your tuple and it's fine.
Pardon?
I was saying the nice thing about Python is like having more dimensions in your DP doesn't make it hard because you just add like another variable to the cache and
it's just finding out the DP though.
Yeah, for sure. So you have some problems. I didn't see which one you ran into.
Let's see. Int It's not super scriptable. Yo, John, how are you accessing the internet from where you're at? Okay, wait. This guy's like out of town. dp.nice. Let's see. Int object is not super scriptable. Okay, it's.
Oh, so I think rolls left is not an array. Rolls left is a number in your code. So you're trying to like access rolls left, but it's a number.
I need to pass down roll max here.
Okay.
Right. So I pass in rolls left, and I pass in roll max here.
Okay.
Okay. Let me just debug that code real quick. What? Duplicate. Oh, rolls left. Oh. Let me just do this roll max. Just not change the parameter name. Roll max.
Yeah, that's why I also used to just make the DP and the other ones I don't have to pass down like 5 variables. But either one works.
Positional argument. Okay, we have a dice. We're forgetting our cache. Okay, the index out of range. For dice in 1 to 7.
Oh right, so your dice is 1 to 6, but you're using dice as an index, so it's off by 1.
Rookie move. That's crazy. 0 to okay, yeah, to 6 here. Or just say 6. Everything wrong. What the heck? 34. Okay, let me think about it.
I mean, it's pretty complicated, so okay. So you have another error. I'll just point out to you. Maybe you have more, but in line 10, you're saying if my current number, like if I don't have enough rolls, I'll continue. But otherwise, when you DP, you're basically just like passing in the roll max.
-1
all the time.
Yeah, sorry, -1. Forgot that because that means like I chose it now. Okay, that helped with a few. Because that means I chose that.
No,
dice.
that wasn't the error actually. So by the way, so these dice are technically 1 through 6 or whatever, but you can actually just use 0 or 5. It's the same question. But the problem is, so if you don't have enough rolls, you're continuing. But what if you like? Let's say you're on a die and you do have enough rolls. Think about what you're doing. Like let's say you're on roll dice number 1, and you've rolled it 3 times, and you can still roll it more. Like what would happen in your code?
And I could still roll. Okay, wait, say it again. Like I'm on dice. Let's say I'm on dice 1.
Mm-hmm. And you rolled it 3 times, and you can still roll it more. What would happen in your code?
Okay, so pretend it goes 1. So it would.
So you rolled it 3 times, and then
it would recurse on that. So it would choose that dice again 1.
Mm-hmm.
So it basically roll it again, like choose the roll and add to the path.
Yeah, so when you do this roll max dice -1, roll max is a starting array, so it would just like reset it all the time.
God. Yeah, you're right.
So for like a new one, it makes sense to do this. But yeah.
What we can do is like update the roll max -1 and then +1 after. Use it.
Well, can we just extend the if statement on line 12 and then like kind of have two cases if we can roll or not? Like if we do have the current one, if it's 0, continue. Otherwise, use the new number.
Wait, can you repeat that?
Yeah, so you're checking like, is this die the same one I rolled? So can we just extend that if statement to say like, okay, if that is the same one I rolled, if the roll's left to 0, continue. But if not, let's just update my number to what I had before -1. Does that make sense?
Yeah, I see. Like if.
Because line 17 basically just resets every time. So you would just be able to roll infinitely.
Yeah.
Yeah.
If dice is equal to the current number,
Mm-hmm.
we're gonna have what condition? Else. That makes it simple.
Yeah, you could do it that way too. Yeah.
So like result +1. Here, what we're gonna do is like, we're gonna take the rolls left -1, and then like, if we choose a different one, we kind of reset.
Yeah.
Oh my god. 111. Okay, let me look over this case. I didn't even know how to debug this.
Oh, so you forgot one last thing, but it's pretty simple. You just need to modulo the numbers.
Oh, yeah.
So that might be the case too.
Modulo 10. Harold, I'm getting cooked, huh?
Getting cooked. Okay, that it worked.
Hope so.
Hope so. If not,
Oh my
there's
God.
wrong
Wait.
answer.
10 to
Interesting.
11. But yeah, this is such a low number. It should.
Okay, yeah. So let's see if you let me read it some more. I didn't see anything else that was wrong. Huh? Number 6. I do think this is probably wrong. Well, I'm curious, like if we just get rid of that. Oh no, that just gives me the wrong thing. Okay, so 0 to 6, self to P. Yeah, you're like off by 1 somewhere for some reason.
Okay, 0, 1, 2, 3. Oh, because I passed in 1 here. That was a bad mistake. Yeah. I passed in.
Oh, I see.
Passed in 1.
Okay.
Please work. Please work. Let's go.
Please work.
You got time for one more? Holy crap. Any feedback on that one?
Yeah, sorry, I was talking to my brother. Yeah, I would say, so it's definitely difficult for you to get the dimensions for the DP. Like, you struggled there.
Yeah.
But I feel like the hints I gave you weren't that obvious. And you were able to, like, get the hints and unblock yourself. And then you were able to actually, like, code most of it yourself. You missed the 1 edge case. But, yeah, I would say this is, like, a harder problem. I do think, though, like, for like a harder company, or if they only ask one question or like some Google thing or something, I feel like this is pretty reasonable. Like it's not like some insane thing, you know?
Yeah. Honestly, I just haven't been challenging myself. Like this is a good question.
Right. And that's the other thing I would say is like if you only do really easy problems, or you know, whatever, it's kind of hard to get better. So I feel like if you do these more often, then you would just like see it faster, do it better, and make less mistakes and so on.
Yeah.
So yeah. I mean, you were getting a little bit lost in the end, but also it's kind of complicated, so that like I don't really blame you there. I will say, yeah, like making this DP outside maybe overcomplicated things. Like I would just made it in here, and then you wouldn't have to pass down like 7 fields.
Mm.
But that's personal preference. Like if you can do that and you can do it correctly, then sure. So yeah, I'd say overall, like definitely not bad considering. Also, you said you started DP like a month ago or something, right? Or like 2 months ago.
Yeah, well, I did I learned DP before. I just haven't really, I didn't brush up on it. Like DP is not new to me. Otherwise, I would not have been able to do that at all.
Yeah, got meta in the bag. I mean, yeah, I guess the meta stuff is also kind of like it's kind of different criteria, right? This is more like, can you solve a pretty hard problem? Meta is more like, can you solve a medium problem but really quickly and like explain your code really well, and like it just tests for like different things. So, yeah. I guess this would be more like, I don't know, you get asked. I mean, I think like Google or something doesn't do the 2 problems, but they ask harder. And then probably some other quant or whatever, that type of stuff probably asks harder. than meta stuff, I guess. I mean, meta you can also get asked hard. It's just like luck, right? So you can get kind of cooked if you're unlucky.
The thing is, like, why this is so helpful is you're giving me the hints that I need, right? If I was doing this myself and I got stuck, I wouldn't know what hints to take, or I would just get stuck and I'll be like, okay, I'll look at the solution, and then like that's like
exactly.
even worse.
So you're still like challenged where it's like I don't tell you the answer.
Yeah.
I'm just giving you just enough to kind of like unblock yourself and keep going. So yeah.
But I feel like if I was doing this alone, that's why I struggle with these 2,000 elo questions. Like, I just straight up end up looking at the answer if I can't solve it. Then I don't have to struggle through it the same way that I just did right now. But this I actually learned a lot. Like understanding that the path is resetting. That's really important. Yeah. Should we do another quick one? Do you know any one that's like won't be too hard that we can squeeze in 20 minutes? Like
So we can do another
ELO.
one. We can just see. So it's going to be the same ELO, but it's easier in my opinion.
Sure.
It's graph, so it's kind of like inflated ELO. So yeah. So I had 4. This is like the second, or it's probably the easiest one out of the 4. And then I'll yeah. Okay. So let me link. So it's 1761. You can just maybe add me to that one.
Yeah.
But yeah, I've been doing the 2000 plus. I feel like it's pretty good. It's like all like this one I did reasonably quickly. I do actually. The funny thing is, the harder ones for those are the like not DP and graph and stuff because they're not inflated in ELO, and they're actually quite complicated. So yeah.
Okay, cool. All right, let me read into this one. Oh yeah, let me invite you here quick.
But this is what I was doing with the Q4s. Like I would get stuck and read the solution as well, but they were so hard that like even if you read the solution, it's still not super intuitive. And then I coded it myself and I like explained and made a video. And yeah, if you do that for a while, you get really good. So
yeah.
All right, where did you add me into the meet?
Honestly, that question, I don't think they'll do. If it was an interview, they'd just make you do that one question.
No, yeah, it would definitely not be 2. Yeah, I agree. Like if you had 45 minutes, getting that as like a 20-minute would be pretty ridiculous. So yeah. Yeah. And then they just probably wouldn't give hints. They just give you like 45 minutes or 50 minutes. And then if they had to give you as many hints as I did, it would probably be a fail. But yeah.
Okay. Cool.
But it doesn't matter. Like you're not trying to interview. You're trying to like get better, right? So,
yeah, I'm just trying to get better.
Yeah. Because if you only do things that you can like do in an interview and do really well, then like you basically never get better because you're just doing stuff you know already. So.
Yeah. Okay. So we're given an undirected graph. We're given an integer n, which is the number of nodes in the graph, and array edges, where edges are like the edge between two vertices. Indicates that there's an undirected edge between those. A connected trio is a set of 3 nodes where there's an edge between every pair of them. So this is a connected trio. The degree of the connected trio is the number of edges where one endpoint is in the trio and the other is not. Return the minimum degree of a connected trio in the graph, or -1 if the graph has no connected trios. So, okay, let me parse out some of the problems or everything in the problem statement, and then actually look at the example. So yeah, we're given an undirected graph. We're given an integer n, which is the number of nodes, okay? And then we're given a bunch of edges. Number of nodes. And probably the number of nodes is like... Number of nodes. Does it matter? And then each edge goes to ui to vi. Okay. So the n is 1 index, so it's maybe 1, 2, 3. So if we say n equals 6, that means we have nodes 1, 2, 3, 4, 5, and 6. Right? 1, 2, 3.
Yeah.
And then we have edges now, right? Edges. Right. So we have edges. Edges is gonna tell us the different nodes of like from 1 to 2. Okay. Yeah, 1 to 2. Okay, yeah, edges is the undirected thing. So that makes sense. We have our adjacency list, or how we build our graph. So a connect tree is a set of 3 nodes where there's an edge between every node. So this is a connected trio right here. Let's see.
Yep.
Let me see. The degree.
Yeah, so there's only one trio in the first example because there's only like that triangle that's connected.
Okay, the degree of a connected is where there's an edge between every pair of them. Okay. The degree of a connected trio is the number of edges where one endpoint is in the trio and the other is not. Okay, one. So I can't really see the bold, but I see it now if I stare at it.
Oh yeah, yeah.
So what's it called? So the bold. So these are. So we just need to find all of the. Okay, so this one is 3 because there's one connected trio, and then the edges outside of them are just 3. So we need to return the minimum degree of a connected trio. So. So what I'm thinking is, so let's look at this example. There's 2 connected trios. Actually, there's 3 connected trios. Okay, this connected trio has 0, 4, 1, 3, right? But then there's this connected trio. There's this connected trio, 2, 5, 6, and 5, 6, 7. What about 2, 6, 7?
So 2, 6, 7
yeah.
is not because they have to all be connected.
Okay, yeah. Okay, yeah. And then we just need to. So what I'm thinking is maybe what we're gonna do is the first step is like find connected trios. And then once we have a list of connected trios, like loop through each one to figure out the degree of those trios, right? So I think the hard part is just finding the connected trios and like deduping them.
So can you explain what you mean by deduping?
Dedupe those. Like we don't want to 415 or 413. That's one connected trio, but we don't want to look at that twice. I mean, it doesn't really matter. Like we can look at the. Basically, what I'm thinking is like for each node, we see the connected trios that it could form. So with one, we can look at its edges and try to form a connected trio. And then we could figure out how many connected trios are in one, and then figure out the out degree or the degree of that trio. And then we could do that. We can loop through each node and kind of do that. So loop through each node, and then maybe we can speed it up, but like loop through each node, find connected trios, and count the degrees. And like there might be duplicates because pretend I look at 3, and I see that it's part of one connected trio, and I look it up again, but it shouldn't affect the actual result.
Yeah, like if I look at like 265 or 562 or whatever, like it's the same, so it shouldn't matter at all.
Yeah. So yeah, this is what I'm thinking right now. Find connected trios and count the degrees. And maybe one way that I could find the connected trios is like maybe find cycles of exactly length 3. Because if I find a cycle of exactly length 3 distinct nodes. Well, no. Wait, let me see. How do we know something is a trio? I mean, it is a cycle for sure. I guess
so what would be like the easiest thing you can think of to figure out how something is a trio?
Like we could just straight up be like
what would be the brute force of checking if something is a trio?
Like for each neighbor, check if it has a neighbor that points back at me.
Yeah. Well, they're all gonna because it's undirected. But like, let's say, like, if the problem was just give me the number of connected trios, including duplicates or whatever, in this whole thing, what would be the brute force of that? Would like doing no traversal or anything? Okay. Can you think of something?
Wait, could you repeat that question? Sorry.
Okay. Yeah, so it was like if I just say like give me the number of connected trios, not accounting for duplicates, so like 256 and 265 are different. Like what would be the brute force way of doing that without like doing some kind of graph traversal and like looking for cycles and things, like what would be even easier, I guess.
I mean, like the way that I think would be the easiest for me is just
Okay,
straight
what would be
do
the
just
easiest?
straight do a DFS that could only go through 3. Like basically look for cycles of length, or if we could find a cycle by only traversing 3 nodes.
Okay, so how would that look like, I guess? So we start at some node and then we see if we can find a cycle by traversing 3 nodes.
3 distinct nodes.
Okay, sure.
So basically, yeah. So basically, what I would do is, I mean, the brute force way would be like, pop 1 in there, and then pop all of its neighbors.
Mm-hmm.
Or basically, look for 2 neighbors that point to each other. Kind of thing. Or look for without
So
a
neighbors
cap-
will always point to each other, but I guess to give you like if I give you 3 nodes X, Y, Z,
Yeah.
can you tell me if they're a connected trio or not quickly?
Yeah, like well, if I'm given X, right? If I know X, I can
Mhm.
just pick 2 neighbors, Y and Z,
Mm-hmm.
right? I know I'm connected to X or Y and Z, but if Y and Z
Mhm.
also connect to each other, if there's an edge there, then I know that's a
Mhm.
trio.
Okay, yeah, that makes sense. So you're saying like take node X, go
Yeah.
through all the neighbors of X
Like a double for loop through the
with
edges.
a double for loop. Okay, and so what would be the time complexity there?
Like if it's a fully connected
Yeah,
graph,
fully connected. Sure.
um, like if we go through n nodes and we do a double for loop through the other ones, it'd be like that'd be like n squared is like m cubed, I feel.
Right. So yeah, so I guess we can look at the constraints and ask ourselves like, is that going to pass? Because I feel like for hard problems, like you generally just want to start like if you can pass the constraints, you're pretty close to optimal already.
I mean,
For
I
hard
feel like
problems.
with n equals to 400,
Mm-hmm.
and there are no repeated edges.
Mm-hmm.
I feel like it might be past these constraints. The constraints are very small.
Yeah, exactly. So this will actually just pass. So let's try to get a solution like that where we literally just brute force the trios. And then we can try to do some optimizations after that.
Okay. There's like a DP kind of thing. I mean, we might be able to cache, but... Or like remove, like dedupe to avoid...
So let's focus on...
Yeah. I see what
not
you're saying.
deduping maybe, and then we can talk about deduping. Because
So,
like you said, like not deduping doesn't matter because like if I visit 123 or 132 or whatever, it'll give me the same answer, and I'm just looking for the minimum, so I don't need to know how many.
yeah.
Yeah.
Okay, so we're gonna loop for like result equals float infinity because we're trying to minimize some value. So what we're gonna do is I mean, do we need to parse out an adjacency list here? Let me see. I guess we might need to. Do we need to parse out? I guess because we're only given the edges, so we need to parse out an adjacency list. So what we're gonna need to do is, for edge A to edge B in edges, we're gonna build an adjacency list. So we're gonna say from collections. I know this is already imported, but I like to just make sure I remember the syntax. But what we do, we create an adjacency list, default dict with integer, or sorry, it's probably just like a set or a list. Probably just, let's just go with a list. So we could do the double for loop better. But what we're gonna do is in the adjacency list, what we're gonna say is edge A has a neighbor of edge B and vice versa because it's undirected.
Mm-hmm.
So that will parse us our adjacency list.
Mm-hmm.
And then what we'll do is we'll just loop for node in range maybe 1 to n plus 1 because it's 1 indexed.
Mm-hmm.
I think it's one index, right? Just say that at all?
Yeah. Yeah, no, they're all one indexed.
For node in, what we're gonna do is we're gonna pick our node for every node, what we're gonna do is we're gonna double for loop through the neighbors. So we're gonna be like for for I in range, or we're gonna be like, let's get the neighbors first, right? Neighbors equals, we'll access the adjacency list. We'll grab the node. That will give us a list of the neighbors. And then what we're gonna do for I in range length of neighbors, for J in range like I to the I plus 1, because we already chose I to the length of neighbors. We're gonna do this double for loop, and what we're gonna do is neighbor A, neighbor B, and what we're gonna do is we'll say neighbors at I and neighbors at J. So that will give, like, we're positioning the two nodes. So I already know I'm connected to these two ones. So what I'm gonna do is I'm gonna be like I need to check if they're neighbors. But they're not, like with the list it's gonna be inefficient, but we can speed that up. But we just need to check if they're neighbors of each other. So if adjacency list of, if the neighbor B is in the adjacency list of neighbor A, so we get the adjacency list of neighbor A, these are the neighbors. So if A is pointing to B, like that's actually a connected component. Like that's a trio.
Okay, so if it's a trio, how do we actually calculate this thing that we need?
Yeah, so we do, if it's trios, we kind of need to subtract like 3. So we need to figure out all of the, wait, there's gonna be we could just calculate, add up the length of the list for each of the edges here. Add up the neighbors and do some math to like delete out ones that we know are each other. So pretend for this one it has like 3 edges. So I think
let's take a look at maybe example.
We just have to minus 9.
Let's take a look at example 2, because that kind of shows the ones we need. So the one on the left, what's going to be our total? Like how many edges does each one have?
Yeah, it's going to be 9. So it's going to be like 1. Or wait, this has 2 edges. So this one is going to have, let's look at a simple case.
Yeah, that's like the simplest one. That's what I want to do, that one.
So we'll do like 4. This is going to be like 1 and 3. Then we're going to have 1. 1 is going to have 4 and 3. And then 3 is going to have 4 and 1. So if we add up all the edges, then we kind of just need to delete these edges, 4 to 1, because those don't count. So we just need to minus 8, kind of thing. We just say like we can loop through the edges.
So how many edges do we have total in this thing? Like in this, like how many edges does each node have? I guess
8, or sorry, 6. Sorry.
Yeah. Okay.
6. Sorry. So basically, what we need to do is like we need to sum all the different nodes, the length of this, and then minus by 6 to remove the ones that are connected to each other, and that will give us like the ones that are the degrees outside.
Yep. Okay, so let's do that.
Okay. So what we're gonna do is like total sum equals 0. Let's say for Roger, what's up? So for neighborless, wait, what are we doing? We're looping through. Okay, for just say like current node, so current node, whatever, and then we're gonna loop through. We're gonna loop through the current node. We're gonna loop through the neighbor A. And we're also gonna grab the neighbor B. And what we're gonna do is we're gonna say total sum plus equals the neighbors of that current node, like -2 or something. That'll get us there. And then basically what we do is result equals the min of result and the total sum.
Mm-hmm.
So yeah, this captures degree. Yeah, I think just that simple for now.
Mm-hmm. So let's see if we have any problems here.
We
can try to run it.
Takes up bounds. Oh shoot, I did -1. Wait, index out of range. Where's neighbors?
So what is neighbors?
Oh, sorry. This is adjacency list, and we have to capture the length.
Mm-hmm.
It might be slow. Should we try running it on the big test case?
We can try, yeah, sure. And then we could see like what we could optimize.
Yeah.
I think you mentioned some stuff.
Like deduping the set, like adding a set there, like add a set.
Yeah. So yeah, I think adding the set, like what do you think? What do you think matters more? I guess. Oh, you got. Okay, so you can fix that one first.
Okay. If none, if so.
Okay.
It's very slow.
Yeah. So what do you think will
Wait, what happened here? Oh, sorry, negative.
Oh yeah, you need -1 instead of none. Okay.
Like
what do you think is going to make a bigger difference? Deduping or adding a set?
Probably deduping.
Okay.
Wait, let's see. Maybe adding a set is gonna make a big difference here.
Yeah. So what would this be with a list instead of a set?
Like O-Van, just like searching for.
Right. So this would be like n4 or something, right? With a list. So I think a set would be more.
For neighbor B, this one, right? This function right here is like O-Van.
Mm-hmm. Yeah. So I think the set would actually be better. Plus it's easier, so we can do that first.
Okay, let's go set. Add. For node and for nabes equals. I'm gonna do. I'll just turn this into a list.
Okay.
Dot keys. Neighbors.
I don't think you need keys. I think just list adjacency list nodes are already a list. I think that'll just give you what you want.
Then maybe we can dedupe worst case.
Mm-hmm.
Let's see. Oh my god.
So where are we? Adjacency list. Maybe you can just try running this one test case and see if we're close. So add that test case to your and try to run that. Because yeah, I'm curious if you're like still way off or
right there.
Okay. So we're pretty close to getting something. So yeah, so
maybe deduping.
Yeah, deduping, and then so for the set, are we using the set everywhere, or are we using nabes somewhere still?
We're using nabes.
Like, are we iterating nabes I? Yeah, what does that do? What does line 29 do?
Well, it picks like 2 random neighbors.
Oh, okay. So that shouldn't matter. That shit's fine.
And then we're seeing if they're actually connected to each other, and if they are, then we do this. But for here we kind of loop through the node. Maybe we can cache that. Oh no, like the.
So let's try. Yeah, I guess let's think about deduping. I think this is also one of those questions that like barely passes, so it's kind of annoying. So
if I ran it, or like there's some parts that I could just speed up here.
Yeah. So So basically, like, so how could we dedupe? Or like you said, the problem is like we're hitting all three. So how do we like do the earliest possible dedupe, and then maybe, yeah, like I guess what optimizations can we make to just like dedupe and also break as fast as possible? I guess.
Wait, sorry, could you repeat that?
Yeah. So what are some optimizations we could do to dedupe and also break as fast as possible if we do have duplicates? Like ideally, we don't want to have like duplicate, not duplicate, duplicate, not duplicate. Like, is there anything else we can do? Or I guess let's think worst case. Like worst case, let's say the graph is fully connected. How can we optimize that to dedupe, not have to do so many searches, and then yeah, like things like that. Like, because that would be the worst case, right? The graph is fully connected. That would be the slowest. So how do we handle the deduping and then maybe restructure our code, or just handle deduping, start off with there? Because right now we're just trying every three possible.
Yeah, if I do 4. Okay, let me think about the first one, deduping then. So if we do 4, 1, 3, do I need to check 4 again? Well, I need to check 4.
Yeah, so like
because
if you do
it might
4,
be a
1, 3,
certain-
you don't want to check 4, 3, 1 and then 1, 4, 3 and so on, right?
Yeah, maybe we can sort those 3 and then like have a set. It's like we need to check. Wait. But then this part is not even that much longer. Like always save from the dedupe. Because we still... Wait, maybe we might need to able to update the set. So it's like 4
Yeah, so we're still looping like, yeah, so you're kind of on the right track. We're looping through all the neighbors twice no matter what. So can we kind of like not loop through all the neighbors twice and maybe do some like you said, maybe sort or something, and then so we don't have to just like loop through all the neighbors twice. Like we can just say like, okay, for the, like when this doesn't work, nothing past this will work, or something like that. You see what I'm saying?
Yeah, if nothing passes... Wait, sorry, could you repeat that? I didn't get it.
Yeah, so we have these like 27, 28. We're checking through the neighbors twice. So ideally we want to have something like these are all valid, and then once we get past some number, we would just want to say like, all right, if this is not valid, then like the rest of them aren't either. Ideally, instead of having like this works, this doesn't, this works, this doesn't, because that doesn't really save us anything.
Basically, you're saying here, if this doesn't work, like an early stop.
Yeah, have like a break or something. Yeah, exactly. Yeah. Is there any way we can like structure our data or something, or maybe redo this? Yeah.
Like we're already looping from 1 to n. Right.
And the same thing through the neighbors. Like we can have an earlier turn there. Like for example, so I guess in general, like let's say you're doing like a subsets problem, and I say like, you know, give me all subsets, but I don't want 1, 3, 4 and 1, 4, 3 and 3, 4, 1. How would you handle that? Like, what's the easiest way to handle that?
Like sorting it usually?
Yeah, exactly. So is there any way maybe we can like, when we make our graph, like if we're on a 1, for example, if we just say like all our trios are in increasing order or something like that, you know, and then like if we're on a 4 and a neighbor's 1, we could just be like, well, we don't like, that's never going to be good because we're only going to do 1, 3, 4. We're never going to do like 4, 1, 3 or anything. So is there any way we can like modify a graph a little, or some other, or maybe change these for loops around to avoid, like have earlier turns everywhere?
To avoid earlier turns everywhere, yeah. I think we'd probably just need to sort the trios or something.
So instead of sorting the trios, I meant like, can we sort the edges or nodes, or nodes?
Like here, right? Here in the neighbors, sort the nodes in some way.
Yeah, like let's say, like for example, an easy example would be like, let's say 1 has neighbors 3 and 4. If we just store the neighbors in like a sorted order, then whenever we're at a node and we're going through the neighbors, we can just say like, whenever we hit a neighbor that's smaller, we'll just stop.
I see. Or no neighbor that's greater. Or we need to start if we're at 1, we should only start from neighbors
that are greater or something. Yeah.
And we could just skip. Skip.
Yeah,
But then we skip
the
this part?
rest. Yeah.
So let's do that. This
Okay.
sorted. Wait. Sort. That'll give us our sorted neighbors, and we'll say
Mm-hmm.
if I is less than the node, less than or equal.
Mm-hmm.
Continue.
So do we even need to continue, or can we just break because we're sorted? Or I guess like maybe like which way do we want to do it? Increasing or decreasing in your case when you're sorting? So you want it increasing. So like if we're at a I guess we can do it. We can do a continue. I think that's fine. Okay, let's try this. Yeah. So essentially, when our neighbor is or should it be I or should it be the value?
Yeah, you're right. Damn, I'm getting cooked.
Getting cooked. There's actually like a way easier way to do this one as well, like that I can show you.
This was way more complicated. Yeah. Let me get this. Nice. Okay.
Did it work?
Yeah.
Okay.
Because the video's already 1 hour 10. I might let's just close it off with some thoughts, and let's stay on so we could talk about. So you could just teach me the other stuff. Maybe that could be enough.
Yeah. So some thoughts. I mean, I do think this one is just kind of hard to hit the runtime to pass. But some thoughts for this one is, let's see, like what problems you had, I guess. So definitely, I would say some problems you had was you were kind of stuck in the beginning to like you were trying to do things that were too complicated. You were trying to like if you were trying to run through the whole thing and get all the cycles or something, that would be kind of difficult.
Mm-hmm.
So you need to try to recognize like what's the simplest way to solve a problem, and then like is this going to be fast enough? And so especially for these hard problems, I would try to focus on that. Like, what's the simplest way I know to solve this problem? And then like, is this going to be fast enough to not get TLE basically? And yeah, I guess for leak code, it's basically kind of like when you are doing the harder problems, you kind of have to look at constraints. Like there's no way around it. You have to use your constraints and like estimate a complexity, and then like think if will it pass or not.
Yeah.
And the nice thing is for the hard problems, like the constraints are already going to be pretty tough. So as long as you can just like pass the constraints, your solution will be close to optimal already. Like for easy, you can do whatever you want, it'll pass. For hard, that's not the case. And then let's see some other stuff. Yeah, you're definitely having trouble like figuring out like how do I traverse neighbors? How do I optimize this a little bit?
Mm-hmm.
But the rest of it, yeah, I'm trying to think like where did I give you the hint in the beginning? I guess this is also one of those things, right? You didn't write that many notes, and I didn't write notes on my side.
Yeah.
So then if I do have to write, like if I was actually interviewing you and I went back like 3 days later, it would be hard for me to remember like what you did wrong.
Yeah.
So that's why I'm like in a real interview, I would just have notes of like what you did wrong and what I gave you hints with.
Mm-hmm.
But yeah, you did figure out like, okay, I can just find all the trios, I can count the degrees, and then I can like just do a subtraction. You did figure that out like pretty well.
Mm-hmm.
So yeah, I think overall just maybe write code that's a little bit cleaner. Like you missing the set, I would say, is kind of like the big one that you screwed up.
Yeah.
The deduping, you also did realize that like if I don't dedupe, it'll be the same it'll be the same answer, so it's not that much of a difference. But missing the set, it basically just gives you like another factor of complexity, so that's a big one.
Mm-hmm.
And yeah, I would say for graphs, just try to figure that out, and then the rest. Yeah, I'd say the rest was pretty good. This problem just has kind of like a stupid runtime you need to pass, so that's just more on the problem, not on you.
Mm-hmm.
And yeah, you also did, I think, figure out like the sorting part, at least part of it. I did have to give you like a few hints.
Yeah, you gave me a ton right there, but yeah,
Yeah,
that's good.
But overall, like once again, like I didn't have to do the problem for you. Like I can give you a hint, and then you can go from there. And I think for these hard problems that you're not used to, that's like really good. Like I wouldn't expect you to do all of these like with no hints whatsoever. So yeah, exactly. You're able to, and that's kind of like, I think that also shows like the actual engineering skill, because like on the job you're going to be stuck a lot, and it's like, can I give you a pointer and then you can take it from there, or are you just always stuck?
Yeah.
Nice. I think that is something like people look for. And then yeah, as far as Yeah, I think that's honestly that's honestly most of it. And yeah, like you see, like I do think if you do this level problems consistently, you'll get a lot better.
Mhm.
So I mean, that's just up to you. Like, do you want to or not? But
Oh
yeah.
yeah, I definitely want to. Okay, that makes sense. I think, like with deduping, like I'm just not you. You don't have to do that much in the medium questions. I mean, you do, but not as
Yeah, no,
often.
this one has hard constraints that like you need to do a lot to make it pass. In the mediums, like it's never you don't really have to do this kind of stuff. Yeah.
Sick. All right, cool. I'm gonna end the video here, and then yeah, let's talk about your solutions. Cool.
Okay, yeah. So I would say
Yep.
for the dice one, it was basically the same. So for this one, you can actually just
Can you send me your
instead of
solution? Or you have the
Yeah, let me
solution?
do that.
I'll debug.
What's the number here?
For the dice one.
No, this one. Or actually, I think I have it. Yeah, I literally just like zoomed out and I started looking at yours. Yeah, I'll send you mine though. I think I did this one yesterday. It also had bad runtime as well, but here.
Holy crap! Yeah, I don't have that much hard questions done. Only 57.
Mm-hmm.
It's
Yeah.
like, I
Okay,
need
I'll
to
send
do
you.
more.
I'll send you the mine.
Yo, Green Coder, what's up? Okay, let's answer some questions quick, Alpha, on this. Should I still get an
Okay.
engineering? I go to uni this year. Or time to put the fries in the bag? Okay, these guys kind of trolling. Definitely, both options are good. It's just how much money do you want to make? Let's see. How much time do you think it's optimal to spend trying to solve a question before looking up hints or explanation? What do you think, Alpha?
I don't spend that much. I'd say 10 to 15 minutes. If you get completely nowhere in 10 to 15 minutes, I would start looking stuff. But you don't have to look up the whole thing. You can just look up like a small part and see if it unblocks you, or like look at a hint. You don't have to read the whole thing. Like usually if I don't know, then I'll start reading the solution and it'll say like DP and then I'm like, okay, now that I know it's DP, can it solve from here? If yes, I'll just try that. If not, I'll keep reading. So you can just like keep giving yourself small hints until you're unblocked, basically.
Yeah.
But yeah, I wouldn't spend like too long. Sometimes I even do less. So like if I feel like I'm just getting absolutely nowhere, the problem's ridiculous. Like that's what I did for all Q4 is I looked at it and I was like, there's just no way in hell I'm gonna be able to solve this with no hints. So I'm just gonna start reading.
Yeah.
So
What I noticed is a lot of those higher elo questions are just straight DP. Like those are usually the questions that have a higher elo.
Well, I think DP is inflated. Like if you do a non-DP question that has the same ELO as DP, the non-DP I think is way harder. If you're familiar with DP, I think DP is for maybe like people don't know it, so they don't do well. But once you know it, it's all the same thing.
I see.
So yeah, like there are really hard DP questions, and most of it is you got to pre-process the data, or you got to make some like that dice thing. You gotta figure out the states that aren't super intuitive. So yeah. Yeah, but my solution for the dice is the same as yours, and I linked the other one in the Discord, or send it to you in the Discord if you want to look. Yeah, it's even like simpler. You literally just loop through like every node, and that's how you can dedupe. Because worst case, basically like every the whole thing is connected, so you don't even have to look at the graph. You can even make like a 3D array and it'll work.
So what are you doing? So you're just looking. Okay, you build a adjacency list and say for I in range 1, for J in range this, and you're looking for K, J and K.
Yeah, you just do all increasing, and then yeah.
I see. So you're just looking for. Oh, I see. So you're looking for 1, 2, and 3. Then you're looking for 1, 3. I see.
Yeah,
That's smart. That actually makes it way easier.
Yeah.
Then you just kind of like you did the math too. Yeah, that's smart.
Right.
Okay, can you send me the other one? Do you see? Bro, you're a legend.
I'm pretty sure it's very close to yours, but yeah, let me find it.
I'll send you the problem number. It's like
I can just look it up.
okay.
Dice roll simulation, that one, right? Okay, submission.
This is smart of just going through these ones. Are you gonna keep grinding out these like 2,000 elo ones? This is fun.
Yeah, it's pretty fun. Yeah, because the problems of the day just get really boring because a lot of times it's an easy, and then it takes like 2 minutes, and then I'm like, this is kind of, it just doesn't feel very useful to do them. So yeah, okay, I'll send you the other one. So I like this a lot more, to be honest. Like you also learn a lot of advanced concepts by doing the harder problems that just like aren't never present in the mediums. So
okay, then you just cache. Let's see the difference of mine. Way smaller. If not n. What does that mean? If not n.
If you have no more rolls left, yeah.
Okay, I see.
Yeah.
Okay, I did like this weird thing. That was weird. Result.
Mhm.
Okay. Okay. If I is not equal to last roll.
Yeah, so the last roll is like the
Okay,
last
yeah.
number you rolled, so it's just different names. I think
Okay.
you had the same thing. You called it something else.
Damn, your code is way simpler. It's crazy. Mine's like so verbose.
Yeah, I mean that's most of it. It's like learn how to write code that's like super clean and super easy to understand, and then it's like the more complicated it is, the easier it is for you to fuck up, right? So
Yeah.
yeah.
All right. Sick.
Because I did a lot of mocks with people who are like really bad at LeetCode, and that's their main mistakes. Is like they'll just have like a billion nested ifs, and I think you learn that from working. If you have like chain nested ifs, like you're just gonna make a billion mistakes, so you want to avoid that.
Yeah.
Things like that. So yeah.
Cool. All right. Thanks, Alpha. Let's do this again soon. Let me know next week. I'll prepare some system design for you too, so we can just keep getting better. Yo, we're gonna get good this year, 2025.
Thanks,
We're gonna go.
dude.
Crazy.
You'll be 2,500 LeetCode contest, and I'll finally start doing some.
Bro, that'd be crazy if we can get up that. I just want my LeetCode contest rank to be over 2,000. Then I'll be
I think
happy.
you can get 2K. Like I've seen people who do 2K. It's not that hard.
Yeah.
So all right.
Cool. All right.
Catch you later.
Catch you, man. See ya. Yo, chat. What's up? What's everyone up to? Can you elaborate more on how to learn data structure is good? You said like spend 4 days on a structure, but after theory, should I do problem for that structure's category? Yeah, you should learn a data structure. Pretend I learn arrays. I learned the theory. I learned how to implement an array from scratch. Maybe spend a few days on that. And then after, just spam array questions. So maybe, and go topic by topic. Spend 2 weeks on arrays, 2 weeks on DFS, 2 weeks on BFS. And when you're learning arrays, learn arrays end to end, implementing from scratch. And then like do array questions. One topic at a time. And then once you master each topic, once you master each topic, then just start doing random questions, maybe in like interview list, and then now you're kind of seeing like, are you able to find the pattern for the question and stuff? That was good. All right, thanks everyone for hopping on the stream. We'll do this again. I'm gonna figure out more stream times and figure out when people want to hop on for interviews. But probably gonna stop that there today. That was solid. Raccoon, I might stream later. It depends. I need to make more videos. What videos do y'all want me to make? But I can keep the stream going. I was just gonna literally like do some others. I was thinking, nah, I'll probably stream tomorrow. I'll figure out a stream schedule because I have the next few days off. But let's see if anyone needs. But yeah, Raccoon, nice to see you. Alpha, thanks for the feature. I need to chop up all these videos. But that was fun. That was really good. Alright. Thanks for hopping on, everyone. Catch y'all in the next stream. Probably tune in for tomorrow. Maybe career advice videos. Michael, send me some topics right now. Like, what do you need to know in your career? Maybe I'll just do like a Q&A live stream and collect a bunch of stuff. Yo, what's up, Brandon? Alright, that was good stuff. I'll catch y'all in the next stream. Peace. Have a good day, everyone. Happy Sunday. Get some time to relax. Peace.